Wow, hey, welcome everybody. Welcome to the SkyTour LiveStream. This is Mark D'Antonio, and you'll hear the keyboard in the background, and you can see that I'm not typing, so who is it? It is the one and only Daryl Mason. Hey Daryl, how are you?
Hi Mark, I'm good. You?
Just fine, thanks. I'm hoping we'll be able to look at some nice clusters tonight. You know, it's a really nice night for clusters, especially when the moon is out. What better time to actually look at the jewel boxes in the sky, right? And that's what we're looking at, is the jewel boxes, and that'll be tonight. So we have tons of them, but you know what else is nice? Sometimes just looking at all the star fields that are available to us. It's incredible. And I look at a star field like this one right here, and you know what I think? I think we could be looking at somebody else who's looking back at us. Okay? And that's a feeling that I've never been able to shake ever since I was a kid. I've always looked at the stars and wondering who else is up there looking back at me. And not from like a paranoia type thing, but from a position of thinking that there's just no way that there isn't another civilization out there. I mean, there gotta be. I mean, look at all these stars. All these stars. There's gotta be another civilization out there looking back at us. There has to be. So, that said, I want to welcome you guys to SkyTour LiveStream. We're ready to go. And I got the telescope all up and running. And just to take you on a little quick tour for those that are just joining us, there's a couple new names in the chat I saw tonight. This right here, this is our telescope in the building out there in Arizona in the desert. This is the telescope control system right here. All right, this is the main view. Yeehaw, this is where everything happens. And we see a lot of really cool things here, as the people who've been here before will tell you. And then over here, this is the camera control system. So the most important thing is the exposure setting, and the exposure setting is right here. Okay, you see the exposure right there. It says 1000 ms. That's 1000 milliseconds or 1 second. Okay, so right now we're doing a 1 second exposure, and we're also doing a little extra processing right here, where this yellow thing indicates how much data is being grabbed by the sensor. This is the actual data, and this yellow curve tells you how much. Right? If I was to take that curve away and make it go straight like this, okay, bink, now you can see that there's not a lot of stuff to see, right? And the more if I grab this line right here and I pull it over and I start pulling it to my left here, okay, you see that it's starting to brighten up the view, and we get more and more stars to see. And that's kind of what we're doing. This is sort of a highly processed temporary view. And then if I really punch it, you know, pow, okay, then we get an even brighter view. And all this not the right colors, but it's sort of like a finder, a dynamic finder scope for us. So I want to say hi to Tara, who's here. Tara, of course, is our famous, wonderful artist, very, very creative woman from Arizona who did the door of the SkyTour LiveStream Observatory. I see that we have Mike here. We have, of course, Daryl's with me. Cypher 2 was the first to say, yay, another stream. PG is here. Hi, Petita, how are you? And then we have Susan Woodcarver is here. And DK made it with tonight. And Piggy, how you doing? Good to see you. And then we have Daisy and Zoe Amethyst as well. Hi, guys. Nice to have you with us. Hopefully Lane can join us as well and see the pretty jewel boxes that we're going to show them in the night sky. And of course, there's me. I'm here with you too. So I'm here to hang out with you and see how you're all doing. I'll stick around for a little while, I guess, you know, while you're watching the sky. You know. So that's all good. Anyway, Genghis, how you doing? Greggy Allen is with us. Bobby Burgess, evening to you as well. Bobby, did you start reading the book yet? I want to know. Inquiring minds want to know. The book, by the way, is The Populated Universe, available on Amazon. It's a book I wrote about extraterrestrial life, the search for extraterrestrial life, and how life formed on the Earth, and how we use that as a model for understanding how life forms possibly elsewhere. And none of it is pure speculation. It's mostly, you know, for the most part, it's all science. So I think that's probably the good part. You know, you'll notice I'm looking over this way, and that's because I have several screens. I've got multiple screens, okay, to show me the view. I've got one here, okay, which you can't see, as I just tried, it didn't work. And then I got one there, one there. Okay, and the business is over there, and the actual broadcasting setup is over here. So that's kind of cool. And let's see here. And Lane is here. All right, that's great. Nice to see you, Lane. Thank you for joining us. You know, Lane, you're pretty dedicated to SkyTour LiveStream. It seems. It seems that whenever we're going, you want to come see us. You know, I think that's pretty cool. I think that's really cool. You know, so we're waiting for the temperature of the sensor to get down. Right now, it reached minus 10 degrees Celsius. I cooled the sensor. It's super cooled so that we can actually eliminate a lot of the noise that we see. Right, Donald Kunzer? Nice to see you too. And Skunk Ape Farm is here. Skunk Ape Farm off the grid. Okay, Skunk Ape is a colloquial term for another creature that is rumored to exist. Do you know what that is?
Wolverine.
Wolverine?
Yep. Oh no, I'm sorry. That's Skunk Bear. Excuse me.
Skunk Ape. Yeah, no. Actually, Skunk Ape Farm will tell you, because I'm sure that the name comes from the fact that he or she is interested in looking for the
Sasquatch.
Yes, the supposedly elusive Sasquatch. Yeah. You know, I have an infrared drone system. I've got a fleet of drones here, and one of them actually has a FLIR infrared system on it. And I've offered it to the people that want to hunt for new creatures that may not be found yet, things like Sasquatch and others. And they all want to use it, but no one's actually come forward to do it, and I'm not charging them. So I don't get it. Maybe they don't really want to know the answer. I'm not sure. You know? So it's pretty cool. What we're going to do tonight. So I'm going to spend some time. I already showed you everything around the screen, so you know you got your way around. Oh, and this right here, that's actually a view into the telescope and what it's looking at. So, for instance, like if I want to change those numbers up here in the keypad, right there, right here. Okay, these numbers right here, these are all a way for me to get into the telescope computer and to start to do things. Like I happen to know that if I want to do this one here, you'll notice that the numbers it's going to change. It's going to say set the speed that the telescope's going to go. I'm going to set it to 7. Okay, so that's going to show right here 1.5 degrees per second. It's going to move through the sky. If I want to use it, if I want to just move it directly, like hitting these keys up here that you see the arrows on. If I tell the telescope to go north, you'll see the telescope over my head starting to go up. Right there it goes, and you'll see the sky, the stars in the screen streak a little bit because we're actually having that happen. So now we move up, and then when the telescope steadies out, the stars get nice and round, and now we have a new star field. All right, so that's kind of what we're doing right now. And like I said, I can pull out our view here and change the amount of stars that we're actually acquiring to make it look a little better. Anahata 77, hi there, Bonnie. How are you? Nice to see you. Nice to see you indeed. Oh, Rockstar, I didn't see you. Hi, how you doing? Rock's with us. Rock is in the house. All right, so the other last part of this is this guy right here. This is our planetarium. It's basically a free planetarium that you can get online. It's called Stellarium, and I have it set up to actually operate our telescope. So if we want to go see, for instance, the wild duck cluster right here, all I have to do is select the wild duck cluster like that, and then I have a way of showing what the wild duck cluster looks like in our view. This is our view. Okay, it's our view, by the way. It's a wide-angle telescope. Okay, it is 2 degrees across and 1.5 degrees tall. Right, and that's 4 full moons across and 3 full moons tall. So that's how big this view is. Okay, that said, now that we have the wild duck cluster selected, I can tell it to go there with just a little bit of a key press. And now watch the telescope over my head. Okay. There it goes. The telescope is now moving. And it's going to take a bright star near this and find that bright star. And then it's going to center it automatically. And we'll come back to the view to see it. Okay. So is it going to use one of these stars here in the view? We'll find out. And it's going to center it, and then what it's going to do, see Lambda Aquila, Lambda Aquila, that's actually centering, which is that star right there. So that star is near the object we're looking for. So it centers it up like this, and then it goes to there now in a precise way. So it finds the star precisely, identifies the star, puts it in the center of the field. Okay, right there is the center of its field, and then boom, it goes away. And remember, we're doing 1 second exposures. And then here we see something materializing. What is that? Well, what this is the object that we're interested in. All right, the object that you cannot see with your eye can be centered in the telescope automatically, and that's what we've done here. Okay, so there we go. All right. Yes, I like that. Like Ginga says, skunk ape. Hi. Genghis, how long did it take you to find the skunk in the emojis? That's pretty cool. It initially flagged your comment, by the way, but I told it to show because that's not a problem. Yeah, so this is Messier 11, which is known as the wild duck cluster. And I'll give you an idea. It looks just like empty space with a cluster around it. I get it. But let's try something just to show you here. I'm going to take us to a 12-second exposure. All right, and I'm going to shut off our hyper processing, and you'll see it go to realistically what it should be. Okay, that's what it would look like. But then we're going to do something else. We're going to actually live stack this. We're going to stack separate images on top of each other, and that'll increase the signal, the stars, and any nebulae. And it's gonna put it against. Look at that. It's gonna put it against the noise in the image, and the noise in the image is something we want to have out. So we stack a lot of images, and then the noise will go away. But you'll notice this is just a cluster. But look at this. All over here we have other stuff going on here. Other dark stuff. What is that? Is this an error on the telescope's part? No. This is called dark nebulae. It's dark interstellar dust, dust that was made in the outer envelopes of stars that were about to go supernova. And this dust, and of course some of it was there, in the beginning, but most of it's made by other stars, and it's just sitting in interstellar space, blown away from stars when they went supernova. Okay, and that's something that you see in all galaxies. You see dark dust lanes around the middle of the galaxy's spiral arms. All right, and that's Lane, L-A-N-E, not L-A-I-N-E, like Lane, who is watching us here in the chat. Okay, so this is a stack now of 6 images, and what we can do is we can do a little bit of processing on this just to help make it look a little bit better, and maybe get the color rendering a little better. It's on moonlit nights, it tends to go a little too blue, but let's find out what it wants to do. Yeah, it went too blue. Okay, however, the different colors can accentuate some of the other features. That's why the Hubble palette is used a lot for observations, because the Hubble palette can accentuate differences between different types of nebulae. Okay, but this is pretty cool, Daryl.
Hydrogen's supposed to be red, darn it.
I know. You're right.
The dark nebulosity is showing up well for a nearly full moon, though.
I know. There it is. Yeah. Yeah, and we do have an issue with the telescope. I'm going to be fixing it in just a couple weeks. I'm in Connecticut. I'm operating a telescope out in the Arizona desert. So from Connecticut. So it's a fully remote access system. And I've got one here, too, on this side of the continent as well. And that telescope is actually behind me, but you can't see it at the moment, but I'll let you see it right now. Ready? Here we go. Okay, there it is. That's the telescope that is going to be put back in our building out here. I talked to a builder today. He was here, and I might get them started on building the 8-foot by 8-foot system. It's basically a square building, and the whole roof is going to come right off this building like this. If that's a telescope in there, Okay, the whole roof is going to lift up like this and go down to the side of the building. And it's going to happen automatically with what are called linear actuators. What are those? Well, you know on your doors, they're called door closers. They're those plungers. Okay, the cylinders, they have a little stalk that comes out, and so it doesn't allow your door to slam. It goes boom, and just sort of shuts it gently. Well, imagine if those were powered by a motor and could push out and pull in. I have 2 of those that I purchased for this very thing, to move the entire roof off the building and down the side. Okay, and then back on the building. And those 2 things can each lift 600 pounds. All right, so this roof is going to be a lightweight compared to what those linear actuators can power. It's all good. So that telescope will be back here in that building once we're done. And it's here now. I'm refurbishing it. I've done a lot of work on it. Get it back ready for operations. So it'll be great. All right. And it's going to do a great thing. It's going to do a great job here. And Tara D is asking, is that blue dust due to oxygen? Are you talking about the blue in this image right now, Tara? Answer that for me when you can. I think that that the blue dust, that the blue kind of glow that you're seeing is actually is related to the fact that we have a bright moon out there. But I do have a filter in there. And Daryl's typing it correctly. The reason the sky is blue is because of Rayleigh scattering. What happens is you have red, orange, yellow, green, blue, indigo, and violet light. Roy G. Biv. If you want to remember it that way, Roy G. Biv. Okay. Well, in the Biv end of the spectrum, blue, indigo, and violet, that's higher energy light. The wavelengths are shorter. Okay, red light's really long wavelengths. That's why you can see infrared energy, which is past the visible end, kind of coming up off hot roads. You know that shimmering that you see? You're actually seeing these long wavelengths that are disturbing the images of what's beyond them. So that's otherwise known as mirages. That also makes that mirage appearance too. But the shorter wavelengths can get scattered very easily. They get absorbed and re-radiated in every direction. Okay, that's what happens. So that's what the molecules in our atmosphere do to light from the sun. So that's why our atmosphere is blue. If our atmosphere had different components in it, of course, we couldn't breathe if that was the case. But let's say we had a different type of chemical we were breathing. If we were breathing, say, just, I don't know, krypton gas or neon gas or something, then we'd see different color sky. There'd be a different type of scattering, if any, that we would see. Okay, but because we have nitrogen and oxygen in our atmosphere, we have a blue scattering, you know. So we might see a slightly different color if we had different composition in our atmosphere. As we've been speaking, we have stacked 30 frames right here. I'm going to stop it right now. And because I'll pause it right here. This is the stack screen. This is where all the information data comes up whenever we do stuff. I'm also going to add a little bit. I'm going to add some sharpening. So you watch the screen, you'll see that it's going to get a little bit sharper. Okay, there. Now it looks a little bit more sharp. See that? Okay, so we're going to save this as you see it, but we're also going to save the stack. And if you notice up here, well, you can't really read that with what's up there, but this stack is saved in what's called a FITS file. And what the FITS file does for us is it allows us to just take the raw data and do image processing on it. Now, you'd say, well, what good is that to me? If you don't want to do any processing, it's no good to you. But I'm going to now save this exactly as you see it. And now what you get is this exact image. And you'll say, well, wait, what do you mean I get? Where is this image? How will I get this image? You're going to get this image because we also have a live server that is right now, as we speak, taking all the images we've thus far taken, and it's pumping them all up to the cloud. And that is a marvelous way for us to share all of our work with you, right? And it's free. We give you this just because we like you, you know. So that's the good thing. Now, one thing that we can do, and I'm gonna do this for you. I'm gonna actually show you. All right, so let me go and show you the directory that we'll be in. All right, so here is, okay, this right here is our server, and when you go to the link that I give you both in my Facebook page pinned to the top, or the SkyTour LiveStream Facebook page pinned to the top, or to a link that any of us here might put in for you shortly, okay, this will give you a directory of every picture we've taken in the observatory. And if you look down here in the lower right, what's it say? It says just now. So these are images we've taken just now. Well, let's go see what's in there. Okay, right now it says there's one in the capture, and then we basically have 2 directories, and we're waiting for it to come in, and a processed image is in here already, and the image itself hasn't gotten here yet, but it will be here in a few minutes. All right, so we're getting all the images here for you. Everything we capture will be here, and then you could check it out. Let's give you an example. Yesterday, or 10/18, okay, on the 18th, yesterday, I did a little session just to check things out. All right, and all I did was take some pictures, and this is the picture I took. Okay, this is an image of one of the clusters I took right here. All right, and it's up here, and all these pictures will be up here for you to check out and enjoy. All right, and again, they will be in at when you come here. It'll be at, you'll see this high level, and you have to drill down. When you drill down, you're gonna see. Let me get back to say here. Okay, when you drill down, okay, you're gonna see, okay, Lagoon and Trifid Nebula, Lagoon. All right, and so, but if you click on any of these, you're gonna see processed, right, and then you see stacked. Under processed, you'll see the images that we took for that night. Now, they may not be final processed, but here they are. Okay, they have all this additional detail. So that's kind of what this is all about, trying to give you something to look at and be able to take away. All right, and that's what we do. We want to do this to make it as easy as possible. Okay, back in August, let's see what we did. Here is the Eagle Nebula that we did. All right, there was no moon that night, so this is what we got that night. Okay, this, by the way, was just a 20-second exposure. Ay. Now this is what we're all about. This is what we're all about. You know. So that said, okay, let's go back to our screen and check out the rest of the story. So now, if we look at Measure 11, that's going to be up there soon. It just takes a little bit of time to get up there, but it will be. Hey, Marianne, how are you? I'm glad that you have. I'm glad you have internet up in Strawberry. She's in Strawberry, Arizona. Very cool names. Okay, and of course, Vera Lucia Campos from Brazil. How are you? Nice to see you. Okay. Thanks, Cypher. That's very kind of you. I don't try to compete with the Hubble. And I don't think we can, to be honest. But you know something? We do our best. Yeah, we do our best. We do okay, you know? All right. Let's go check out. First of all, let me take our exposure and drop it down to 1 second again. And you'll see the screen get a little darker. And then we'll do the hyper processing here to make it brighter. Yeah, Susan asked a good question. We wouldn't see the colors per se in the night sky. That's a limitation on our eyes. Okay, so we wouldn't see the beautiful reds of the nebulae. Although without an atmosphere, we'd see the nebulae brighter. So it's possible that we might see a little additional color than we might see without the atmosphere blocking a lot of the capability of our eyes to discern it. But nebulae are not bright enough to be seen so brightly that they're like as bright as, say, the moon or something like that. There's no nebulae that are as bright as the moon. And you can discern color on the moon in a telescope because the moon is bright. And you might think, well, the moon is gray, dark gray and light gray. No, it's actually got browns on it, and it actually has some different colors that you can discern. There's some reddish browns as well, and depending on where you're looking on the moon, you can see that. But if we didn't have an atmosphere, and of course we all had spacesuits or whatever, then our sky would be black. There would be no such thing as light pollution, because light, the reason we see light pollution is because there's an atmosphere with water vapor in it, and the water vapor is reflecting back and scattering light from streetlights. So that's when you see, we call it a light dome. I was at Devil's Tower in Wyoming, and Gillette, Wyoming was 88 miles away. And when I looked toward Gillette, it was right where Devil's Tower was standing up, and in the distance beyond it was Gillette, and the light dome from Gillette, 88 miles away, was easily silhouetting Devil's Tower. And that's because there was water vapor in the atmosphere that was reflecting and scattering the street lights and so forth in Gillette. So without an atmosphere, we wouldn't know that there was any light pollution at all. We would never see it. So it's pretty cool. Hello, Sashil. How are you? Sashil Nagarajan, I guess. I'm Nagarajan. You have to help me get the accents on the right syllable there, Sushil.
Sushil had a question.
Okay. Let's see. Oh, okay. She said, she. Could you share what would be the cost of your setup, and would you provide technical help to educate the same for India? And of course. My gosh, I'd be happy to do that. We did classes with, we helped actually start doing some classes for a guy in Bangkok, and did them interactively. He had his class that he had of his kids. They were in live with us in the observatory because of the time difference, and you'll have a similar time difference, so you might actually be able to actually do that. Hey, Nick Tesla. So Sheila, the cost that is set up. Okay, if you look at the telescope over my head, okay, that telescope and the building approaches about, I'd say, $11,000 US. Actually, more than that, about $12,000 US. Okay, and I would tell you right now that the spider webs are free. Okay. Okay, we have some spider webs here that you can see, and they're in front of our camera. The other night we actually had the spider crawling up and down. It was actually kind of cool. It's like, boop, boop. Hey, what was that? The spider going up and down. But setting it up remotely, not a problem. That's all the software that I'm using right now is free. Okay, this here is free. This thing here, okay, right here. This is free. It's a telescope control program. This program to watch the telescope is free. This program here, I paid for the professional, but you don't need to. Okay, you can use it without that, but I did because for the cost, which was like $25 American, I mean, it was like nothing. Okay, and this here I haven't paid for, but I could. It's 18 euros. Okay, that's nothing. So I could pay for that too, but it works just what we use it for works just the same. But there are things that do cost, and I'll show you right here in getting into the observatory setup. Okay, this is the all-sky camera. We got a bright satellite that went through. The Arduino, that is the electronics that controls the observatory, like opening and closing the roof. Okay, what's not free about that is the fact that I wrote a program to do that. It's not hard. This is the thing that's free. These are the IP cameras. This is free. This focuser that you have to focus the telescope. The focusing system is not free. Okay, the telescope, of course, is not free, naturally. Sharp Cap is what I'm using to acquire all the images. The camera's not free. It's a dedicated astronomy telescope camera. Stellarium scope, free. Stellarium, free. In other words, this planetarium that controls the telescope, right? This right here, this is free. Okay, and free is good. I promise. Okay, so that's what we use, and whatever you need, I can help you figure that out. You can find me on Facebook. You can find me in several places on Facebook. You got SkyTour LiveStream with Mark D'Antonio on Facebook. You can go there, or Mark D'Antonio on Facebook. If you look online and you look for my name, you're going to find all kinds of productions I've been associated with and worked on. But the Facebook site is probably the best one to get a hold of me, because then through Messenger we can converse and go back and forth and talk about the specific needs. All right, so hopefully that answers your question. All right, okay, excellent, Sushil, thank you. And hi, Do W is here. What's going on? Yeah. Okay, so
One thing real quick, Sushil. This is Daryl speaking. That was Mark doing the talking. I'm just the standby.
What does that mean? You're not a standby.
No, I mean, I think he was thanking me, and it was you doing all the work and the talking. I just wanted to clarify.
Oh, no big deal. As long as somebody
Mark
says
is
it.
the captain of the ship.
No, I'm going down with the ship, see?
Hey, we were talking a minute ago. You want to be rich?
Me?
Yeah.
All right, I'll change my name to Rich, I guess. I don't care.
We need to invent. We need to cross a Roomba with a drone and put a feather duster on it and set it out in your observatory.
Yeah.
Imagine the possibilities.
Oh, yeah. But it would have to levitate, because this camera is around 5 foot 4 inches off the ground. 5 foot 3 inches off the ground.
Well, that's why we put it on a drone.
Okay.
Thank you, dude. That describes me well.
No. Nonsense. He's not funny. All right, let's go find something else.
Hey.
Good galactic green tea to Daryl. I like that.
Got some green tea right here, Genghis.
So, Shield, no problem. I actually think that any outreach, I mean, I have a degree in astronomy, and I actually spent my life in observatories working on projects and stuff. I have taught university and kids and from all levels, adults. And I think that it's very important to consider that astronomy is probably the only science generally where we can't touch what we study ever. You know, scientists studying volcanoes can grab magma and can grab, you know, magma out of the ground, lava when it's flowing, and they can study its composition directly. They can study lava rocks, they can study fossils. But in astronomy, we only have the light itself that's coming to us from the objects we see. Although that's changing, because we now have some sample return projects coming from beyond the moon, which happened in the 60s, okay, from asteroids like Bennu and other asteroids. We're actually sampling them. We've been to comets and landed on comets, but again, we haven't sampled any cometary debris yet. But man, we're getting there. We're getting there. I'm really pleased with how it's going. You know, I'm going to do a little something here. I'm going to drop us down a little bit. I'm going to center this in the field, and I got a reason for doing that, as you'll see. First of all, I'm going to reduce the speed. Instead of 1 degree, 1.5, it's going to be 1/4 of a degree per second. Now I'm going to go north again a little bit. We'll get off this object here in just a sec. Okay. Okay, one more little. By the way, we don't have our Starlink satellite out there yet. I have Starlink coming, and it's going to change the nature of how we do stuff, because I have to click a button and wait 1 second, because that's how long it takes for the internet, or sorry, the satellite internet we currently have out there, which is called Viasat. That's how long it takes for the signal. It's delayed. It's delayed. The system I'm using is almost instantaneous, but it really is. It really is, unfortunately, something where I just cannot stand this 1 second delay. You actually have to live 1 second ago, with everything you do, and that's terrible. But I have to.
That's a 21st century problem.
Yeah, that's actually very true. You're actually very correct. So Shield says, totally agree. Astronomy also enhances your vision and makes you appreciate the creation and the creation. That's correct. That's right. You get to explore why it's here and how it's here, and I think that's just a very important aspect of all this.
Yeah. Einstein supposedly said, "My sense of God is my sense of wonder at the universe."
Yeah, that's correct. And in a sense, isn't that what it is?
Sure, it is for me.
Yeah.
Ultimately, I do it for the beauty of it.
Yep, as do I. Okay. Okay, we are. Make sure I'm at the right spot. Yeah, 1851, 18. Okay. I just synchronized our coordinates with the planetarium and our telescope. Make sure everybody's talking the same language. And now we'll back out of here for a minute. And I want to take us now from that cluster to this guy down here. This is a smaller cluster, but I want to show you these jewel boxes. That's what we're here for tonight. So you'll see the telescope move, and then it's going to try to find the bright star nearby. I wonder if it'll do Beta Scutum. Beta Scuti, I wonder. May not. It's going to find a star that's near the object we want. And, okay, it's going up there. All right. Okay, Lambda Aquila again. And then it's going to jump down to our spot. It sort of like goes to that one spot, right? It goes to a star that it knows, centers it perfectly, and then goes down to the object that it knows the exact distance to once it centers the star. It's a very intelligent system. Okay, and here we go. The telescope is moving, and now we're going to be lining up on our object. And if I come back to our screen, our main view, we'll see our cluster. Look at that. This little cluster right here. This is it. I know it doesn't look like a cluster, but it's the cluster. You can see that we're in part of a star cloud here. And there's something here, too. I think we should do a longer exposure here, Daryl. What do you think?
Sure.
Yeah.
If you're in the clusters tonight, you ought to move over and do the Scutum star cloud next.
Oh, I think that we should. All right. Let's now take and do a... and again, remember, we have a nearly full moon now, guys, and we've already seen dark nebula. I think that's pretty cool.
Yeah.
Well, you know what? It's hard to be feeling bad about things when you've got a beautiful night sky overhead, and so I really appreciate the sentiment, because I need it too. We all do. It's good to see you, my friend. Thanks for coming. Yeah, see, everybody agrees with you too. Cypher agrees with you. Petita, PG, she agrees with you as well. Pretty cool. All right, so let's take this. We'll do 12 seconds again, and knock off our hyper processing so you can see what it really looks like. And now we'll go into our stacked view again, and I'm going to clear this. That's the old one. And now we'll see the new one. Wow. Now that looks pretty cool. Okay, you notice how this looks mottled over here? That mottling is due to the noise that's still present, but we're stacking. We're adding exposure on exposure on exposure on exposure to increase the signal that is the starlight and the dark nebulae and stuff, and get rid of the noise, the random noise in the sensor. So I think that's pretty cool, you know. Tara says group therapy. Yeah, you're absolutely right. I've heard that a lot. You know, people say that this feels like group therapy to them. Well, it does to me too. You know, and I don't ever dismiss the importance of having a good group therapy session with a bunch of people that are like-minded. You know. Yeah, look at Ginga says, you know, all the STLS tribe are awesome. Well, you know what? You guys all make the tribe. I'm just a big mouth that started it. But I'm not the guy that, you know, made the tribe. You did. You know, and I'm so humbled by all of you. So here you can see this beautiful star cloud. You see some dark nebula in here. I think I can enhance that a little bit more for you, too. As soon as we get a few more exposures, it'll be really cool. All right, so here we go. I'm going to try that right here. Maybe just darken her up a little bit. Maybe try this. Okay. Yeah, that's kind of cool. And the color, like I said, with the full moon, it doesn't generally do the color very well. But that's just unfortunate, but it's what it does. Okay. So let's come out of here for a sec and see what we got. Wow, you can see some really interesting dark nebulae down here. You know, considering that the moon right now looks like almost a blue sky out there, it's really kind of bright. You know, you can't even see the Milky Way with your eye right now out in the desert because the moon is so bright. But when there's no moon, you have horizon to horizon Milky Way, and you don't even have to like look to the side to see it. It's visible right in front of your face. It's visible right over your head, and it is astonishingly bright. So that's pretty cool. This isn't looking bad. You can see our little cluster right here that we wanted to find right there. But it kind of
almost lost in the stuff.
Exactly right. It gets lost, doesn't it?
Yeah.
I can do a little bit more.
Pretty much in the plane of the Milky Way here, folks, and
yeah,
we're going to see tons of stars and tons of dark nebulosity.
That's right. Even on a night like this, I'm going to move the black level so that what you see is green over there is going to get darker. Okay, maybe this will help enhance the view for us. Yeah, that looks pretty. Look at that. You can see now some new little features here. Oh yeah, look at that. A lot of profundity in the Milky Way. Very nice. Ah. Tara says, there's so many stars, it's hard to see. And it actually is true. Yeah, you look at this, right? And you'd be forgiven for thinking I was trying to fool you and I'm looking at just a wet driveway or something, right? Because that's kind of what this looks like. But I assure you, we're looking at many, many stars. And this telescope with its special filter systems on it are cutting through the moonlight and showing you the magical panoply of stars that hides behind the light. And it's only when the moon's out. When the moon's not out, this image is even more profound. I can promise you that. Oh yeah, dude, you're right. These images do it for me. Because you're thinking about it. In our time, at the time that we are existing as humans, we have yet to know how many of these stars out here have beings that are looking back out and saying, I wonder who's on that little planet. I wonder if that yellow star, a yellowish white star in the Orion spur of the galaxy over there, I wonder if there is life on there around that star. And Carl Sagan used to call us a pale blue dot. That's the name of his book, one of his books. And we are indeed a pale blue dot, as he would say. But we have been screaming our presence to the universe for over 2 billion years. And the reason is, of course, because our atmosphere has been building up oxygen in it. And oxygen in smaller quantities that fluctuates can be the result of geology. However, oxygen that builds up and stays in the atmosphere and doesn't go away to any advanced species is going to be something that's being replenished. And they will conclude that we're carbon-based beings, so we look out into the universe for beings like ourselves. Okay? Beings that are carbon-based, that use oxygen to get their energy. That's what we do. That's what plants do. Okay? That's what every life form on this planet does. Almost exclusively. There are some, bacteria that don't use oxygen, but aside from that, aside from anaerobic things, we do have the fact that all carbon-based beings use oxygen. So an alien race is probably going to say, hey, let's look for oxygen. Since we breathe oxygen, in whichever way they do, let's find out if there's other beings out there that do. And they'll do like what we're doing now. And what if they started that search 1 million years ago? They could have. The oldest planets we found are over 12 billion years old. The universe is 13.8 billion years old. So they could be around for a long time. And they would have found us many, many millions of years ago, perhaps. Maybe they were here when life first developed here. Can you imagine that? If life first emerged on the Earth and creatures were out there and beings arrived from a long, long far away, we would not know what to do. Well, kind of like now, we wouldn't. But when Stephen Hawking said we need to keep our head down and not announce ourselves to the interstellar species out there, I said, and rightly so, that sorry, we already done it over 2 billion years ago. And so we're out there, and they know we're here. So, that should be heartwarming. And on the other side, you can say, well, okay, so they know we're here. They've known we're here for a long time. So they haven't destroyed us because why? Well, because that's not who they are, possibly. And there's no reason to destroy us. The universe is big. The whole idea of an invading alien species, that's pure science fiction. There's really no reason for a species to invade us. We don't have anything they can't get in an unbelievable number of places besides Earth. So they would be coming here because they're curious. They'd be coming here because they want to study us. And so that's why beings would be here. Okay, our stack here is up to 41 shots. So I'm going to pause this now. I will save it as before. So now this stack will be saved. And Isabella Melamed from Sofia, Bulgaria has just joined us. Hi, Isabella, out there. I see you joined us. She is someone who is an animator, an artist extraordinaire as well. And what she's done is she has taken our imagery that I showed you from our live directories, and she has come a long way and started doing image processing of her own. I also image process all these, and I've written some stuff within Photoshop, which is my tool of choice, and that allows us to shortcut a lot of the things that people do in astronomy, and that gives us a way to process images even faster and better. And I can make those actions available. Isabella wants them, I'll give them to her. Okay, so here we go. We did this, we saved it. Now we'll clear. And then come out and go back to 1 second exposures. It's sort of the pattern here that we do. 1 second so you can see what's happening, what we're doing. All right. And then we will hyper process. You can see that yellow curve intersecting most of the data hitting the sensor, and there we go. That's what we see. And then back to our guy right here. And now I think we want to go right. Well, we're just going to go a little west of the Scutum star cloud. We were kind of in it before, but I think we need to go to it again, don't you think?
Sure.
Of course you do. I know you think so. So,
You suggested it a while ago.
I know, that's why I'm saying. Because you asked for it. Well, you asked for it, buddy. You asked for it, buddy. Now you're going to get it.
All right.
So I'm just going to drive the telescope there manually because we're right there. Okay, so you saw a little bit of the Scutum star cloud that we were in when we were looking at NGC 6683. What's NGC mean? NGC is New General Catalog. It's a catalog of 7,000 plus objects that are wonderful to look at. All right, because as astronomers we love to catalog things, and so we did. All right, right now on the back of this telescope here, you can't see it, it's on the other side. We have a special telescope that's mounted on top of it, and it's actually picking up a guide star to guide on all this that we see here. And that system, which I'm going to now affect right now, is called Starlock. You'll see it down here on the right. And I'm going to go down and change a few parameters here just to make our guiding a little bit better. Okay, we're going to set the rate of this guiding up here, which is the right ascension. That's the left to right motion. We're going to set that rate to, it's a correction rate is what it is, from 66 to just 5, because we don't need to do a lot of correcting here. And then we're going to go down and change the declination, which is the up down, which is this right here, declination. Okay, that's degrees up and down above the celestial equator, which is just the Earth's equator extended out into space. All right. And the lines of longitude are what we call the right ascension. So instead of degrees in longitude, okay, like we're at 112 degrees west longitude at the observatory here, right here, okay. In right ascension, we basically think of it as there's 24 hours of right ascension because the Earth rotates one right ascension, hour every hour. So we make 24 per day. See, and the stars are at a certain right ascension. That doesn't change. So that's pretty cool. And I know there's more that I could say there, but that's good for now because we're almost done with this. Okay. All right. So we are now set to guiding. This is the Scutum star cloud, and we're going to actually grab this now and check it out too in a stack. I think you'll like this. Again, even with the nearly full moon, we can do amazing things with this telescope and filter system. All right, so we're going to remove our hyper processing system, jump into the live stack, and every 15 seconds we're going to get a new image. I think you'll like it. Hey, weird guy, how you doing? Happy trails to you. I forget the rest. Good to see you again. Something like that. Forget it. Until we meet again. That's right.
Yeah.
Thank you.
Sure.
All right, so here's a Scutum star cloud. We have 2 frames. They'll be stacked here momentarily. There they are. And let's kind of give this a little bit of a better look. Oh yeah, look at that. Now, we'll let this stack for a while and just make it a lot bigger for you. So, everything here is a star. Everything, there's stars everywhere, and this faint, this cloud here is called a star cloud because it's made of stars. There's so many stars that they actually look like a cloud. I think that's been mind-boggling to me ever since I was 9 years old.
They are a cloud.
Yeah.
It's a cloud of stars.
That's right. Yep. And Like I said, I've got a little issue with the telescope. The issue is it's called collimation. That's COLLIMATION, collimation. And that means that the lens on the end of the telescope, that's actually where the camera goes into, or the lens goes into the camera. Then there's the main mirror of the telescope, and they're supposed to be lined up directly parallel to each other, right, like this way. But unfortunately, this one here with the camera is tipped a little bit up. That happened when the telescope had an accident, and the telescope went down too low and whacked some of the hardware, some of the structure of the telescope down low, and that jogged the entire assembly just a little bit. It didn't hurt anything, luckily, and we were able to just fix it, but I have to collimate it and realign everything, and I'll be doing that on November 8th, I think. November 8th. Whatever that Monday is, I'm going to be out in the desert working on it. Monday or Tuesday. Yeah. And Tara Diulis, who's in the chat here, is one of the people that's instrumental, along with Marianne Robb, in helping us. So I think Tara may be able to come out and help with that process. I'm not sure. I know that she wants to tend to the door. She wants to do something with the door to the observatory, which is just beautiful. You know. Tara mentioned the stars looking a little red. Yeah, that's probably not the exactly correct color, and so we need to work on the colors here. This is not quite correct, this color rendering here. But when the moon is out, filters can deliver wonky results too. We get better results. The stars are really more yellowish here, so I would actually pull away on and take back some of the red here, and that's what I would do to get this correct. And actually probably some of the other colors too. Okay, the stars look approximately correct there, but we still have to remove some of the blue here. I'm doing it manually over here, as you can see, so it's not quite correct. So we just have to let it go because of the moon.
And there really are some red stars in the field too.
Oh, there really are. Yeah, see, like right here. Okay, right there. And in fact, most of the stars in the universe are red. They're the red dwarf stars, the M-type stars. And they're very, very small. Typically, they're called M dwarfs. And they're little percolators. I call them little percolators. They can literally live for trillions of years. Our sun will last, say, 10 to 12 billion years. These little red stars can last 1,000 times that. 100 times that, possibly. So we're talking about stars that have long, long lives, and that's what we see in this, that's what we see in the universe. Are these M-class stars. Okay, well, that's quite a bit of stars. Good star capturing. Susan, it's a process to realign it, Susan. I'll have to spend 1, maybe 2 evenings in the observatory to do it. I think that it's important to do it and do it right. And there's a way to do it and make it so you don't ever have to do it again. And so I'm going to be doing that as well. But it is, as Daryl says, it is somewhat nitpicky. There's no two ways around it. Yeah, Tara says, what would it be to go out into space and see the true colors? What would it be like? I agree with you. It's got to be just beautiful. And black dwarfs, interesting. You know what a black dwarf is, Cypher? A black dwarf is a white dwarf that has cooled down all the way. The trouble is, first of all, we wouldn't be able to find them too easily other than their gravity. They would have some gravity. We'd be able to probably do gravitational microlensing to see them. But the problem with black dwarfs is a white dwarf would take a lot of time to cool down. And since the beginning of the universe, there's not a whole lot of white dwarfs that will have cooled down and cooled off to the point where they become black dwarfs. So I'm just not, I can't say that there aren't any, because maybe there's some conditions by which a white dwarf cooled down a lot faster. Don't know. But we don't have the answer to that, unfortunately. We don't know everything. That makes it thrilling. That's thrilling. I love that. I love that we don't know everything. Gives me something to do. Okay, let's go now from the Sagittarius, from the Scutum star cloud down to 1 second again, and bring up our hyper process shot. Go to our planetarium. Oh yeah, Weird Guy says there's probably 50,000 plus planets in that field, exoplanets, right? Planets around other stars. And that's correct. There's probably an awful lot of them there, without a doubt. And I don't think that it's likely that we've seen them all, for sure. I think it's actually rather unlikely that we've seen them all. So I know for sure that we have a long way to go. I also know that there's an awful lot of amazing finds yet to see. We're going to see if we can check this out. Keep in mind that we have, like I said, a 2 degree by 1.5 degree field. So little objects like these little tiny planetaries are going to be hard to see for our system. Altalamane Prior is the star that we're at now. And it's right next to the object we want to see. That's why I picked it. Again, it's Lambda Aquila. And then we're going to be centering up and then moving down to the object. There's the object, and the object that we want will be right where this star is in a moment. And we're going to, it knows where this is, so it's going to put the object we want right where my cursor is. So I'll leave my cursor there for now. And there it is. Right there. Literally right at the end of my cursor. Look at that. Look at that. There it is. No, that's a planetary. Yeah, in fact.
Okay. You said planetary. Sorry.
No, it's all right. What I'm going to do is I'm going to just try a quick little thing here. I'm going to do a 8-second shot here without this modification to it, and let's see if we can actually see the color. It won't unless I get rid of that. That's the previous shot. Okay, and let's try to process that a little. Wow, look at that. You can see it. Isn't that cool? You can actually see that little tiny fuzzy planetary. Planetary nebula is the remnant of a star that has, died basically, and it's right here. See that right there? You see that, like, it has like wings. It looks like the planet Saturn almost. But that's it. That's pretty cool, Daryl, huh? Well, you're just
Really, really small, far away.
Yes, it's really small, far away. That's correct. But it was exactly right at the end of my cursor, like I told you it would be. Jeez, man.
I believe you.
Oh, Susan Woodcover asks, Will you video some of the adjustment process so we can see what it involves? If not, that's okay. Well, there's no secrets here, Susan. Of course I will. Thank you for suggesting that. That's a wonderful suggestion. And thanks, Nick. This music is good, isn't it? I like this music. Does this music meet with your approval, Daryl, or what?
Okay.
Okay. Here we go. Okay.
Susan, it's tweaking little bitty screws, tiny little turns at a time.
Yeah, it looks boring, but you know what? When you see it, it gives you a good feel for what we go through in order to get the perfect shots.
Yeah.
Yep. Okay, I'm gonna get out of this now.
We've talked about collimating laser optics before.
Yes.
It can be maddening at times, just tiny little bits of turns on a screw at a time.
Yeah.
Checking where the laser dot falls.
Mm-hmm.
Test burns and stuff.
Yep. Okay, so here is another one about the same. I'm not going to go to that one though. Let's just keep heading up north, shall we? What's that?
You say you're the captain.
Oh, but I take suggestions. You know that. Okay. I actually wanted to look at this. This is what they say is possibly a binary cluster. I've actually never looked at this. NGC 6755. So we're going to check that out. Again, we're going to go to the star, one of the stars that it wants to put in the middle. We'll see which one that'll be. Check here and see which one it is. Oh, Almazan 1. Or Almazan, however you say it. Okay. All right, and then we're moving to it. Ooh, that's interesting. Interesting. They're calling it a possible binary cluster because of these two potential components here, maybe?
I was thinking one is at about 1 o'clock.
Yeah. Mean this one?
Yes.
Okay, well, let's find out. Let's go see. See, guys, this is fun to do. Fun to hang and do this stuff, right? Check out these glittering jewel boxes in the sky. Let's do 10 seconds on this guy.
Maybe we can do the double cluster later tonight.
Yep.
Tara said she wants to see a binary cluster.
Okay, well that's although that's not a binary cluster per se, they're actually quite far from each other. They are relatively the same size, which is kind of cool.
It's a double cluster.
Yeah, that's effectively what it's called.
They call it.
Effectively. Yeah. I'm going to come back in here and clear this. And we'll do it again. Because yes, exactly. I didn't have the other. Okay, I can see there's several clusters in here, Daryl.
Yeah. Did the image reverse? The one I saw at 1 o'clock before, is that it?
That's this.
Oh.
And I think we're seeing this and this is what you were saying. And now, see that?
Yeah.
Well, let me just check, make sure, because when the telescope goes up higher than a certain amount, that can happen to us. And I think it did. I think it did. I think it did reverse on us.
You see where their position is in your frame there.
Yeah, see? Yeah.
One at 7, one at 1.
Right. That's this one and that one now. Exactly. Yeah. But this is how they're aligned in the sky. This is how they appear in the telescope, but how they're aligned in the sky is how they are over here. Telescopes will tend to reverse images, okay? And we have it set up so that the telescope's going to automatically swap the images, because most of the time the telescope views are going to be such that we're going to be needing that, because otherwise everything is reversed. And you don't want to look at the mirror image of things. You want to look at it how it is. All right, so that's what we're going to do here.
Or could it just be the orientation of the camera?
I don't know if it's the orientation of the camera. I think that it might be the fact that the telescope is lifted above the zenith, effectively, in the Altaz mode, effectively. And it's looking backwards now. So it has reversed the images based on the fact that it's now looking backwards over the top.
I understand.
You see what the telescope's doing right there. Yeah, it's kind of going up toward the back. Yeah. All right. Well, what we can do, though, once again, is I'm going to just do this again here. I'm going to, I've got my cluster there, and I'm going to make sure that I'm aligned to it. Good. Yes, sirree. Raymond, oh my gosh. Thank you so much. Nice to see you, Ray. Thank you for coming out. And Raymond, thank you for the emails. The emails are really good and they are helpful. I'm thinking I may talk to you about that at some point, of course. But thank you for those. And thank you for the donation, Raymond. Wow. Okay. Yeah, that's definitely... It's hard to know the distance sometimes to these clusters, you know? Very difficult. Wow. Okay, let's just come in here and check, do a little bit of this processing here, drop down the brightness a little, increase our contrast. Let's see what we got. Yeah, okay, we'll pause this here. And we'll save the stack, why not? I mean, otherwise that's 35 images stacked, or 25 stacked, so that's pretty good. Okay, Raymond, thank you for coming by. It's so good to see you. Wish you could stick around for the whole stream, my friend. Okay. Alright, and now we'll get rid of this. Come back here. Go here. Alright, and then do this and get our hyper processing done. I know, Raymond just got here, and then of course he's gone now. What the heck? That's right, he had things to do. Thank you, Raymond, if he's still here. Okay. All right, so now let's go check out a few other things up on the northern side of the sky. Actually, we're going to stick around in this location for a little bit. There's Altair, Terra Z.
My favorite.
What?
Terra Z is one of my favorite stars.
Oh. Yes, it's got...
You know, I have a problem with Stellarium, their artwork. That's one of the particular examples.
Yeah?
Terra Z is the top of the eagle's head.
Okay.
Altair is the eagle's eye. And that star over a little to the left and down a bit,
Yeah.
that is the tip of the eagle's beak. But you see, they have the head facing right.
Instead of the beak being here and the eye here and the head here?
Yeah.
Yeah.
Artistic license, I suppose.
Yeah. Well, we're actually coming to your favorite star here, Daryl. I think this is Terra Z right here. I believe we went to Terra Z. I was going to Altair. Maybe, I don't know if it actually did. They told to go to Terra Z, so maybe it's going to Altair to center it, and then it's going to go to Terra Z. Which
Terra Z is just a fun little star.
Well, let's see what it looks like. I want to see if we can see the color. It's definitely a reddish star. Yeah. Well, let's just try a quick 5-second exposure of Terra Z here. And see what we got. Here it comes. Yeah, you can see it as a little, the filter tends to color things a little bit on the blue end. So if it's red, it'll color it kind of a purpley. So that's definitely purple. So that's a red star. And we could color correct that to get the right color as well. Yeah, that's very cool.
Isabella, that's kind of hard to say. It just, it always jumps out at me when I look up at the sky at the summer triangle. I see Vega and Deneb and Altair, and Terra Z is always right next to Altair, and I just like seeing it.
Yep.
It is really, is there anything special to the star? I don't think so.
It's just a nice color.
Yeah, it helps me see the eagle shape also.
Okay. I wonder if we're gonna, what star we're using here as a jumping off point. Oh, that's Albireo.
Yeah.
Make sure if I can get this to show you guys before it kicks us out of here. This is the double star Albireo right here. See that? Orange and blue. It's going to center it and then it's going to go away. But there you go. That's orange and blue. That's a K star. Now it's gone. And the blue star is a B8 star. So it's a B star with a, within the B's, it's a 0 through 9. So it's an 8. And the K star is like a K3, Roman numeral 3. Giant star, which is an orange star that has left the main sequence. It is no longer fusing hydrogen into helium. That's the orange star. This fuzzy thing is one of our favorite things, and I'll show you that. We're going to do a, let's say, I'm going to try to go a lower rate this time. I'm going to say 10 seconds. That might be even too much. It's such a bright object. This is a bright planetary nebula. And you'll see it.
That's Barbell.
That's what? Yeah, that's right.
Barbell Nebula.
Not the Barbell.
Dumbbell.
Don't call me a dumbbell. Yeah, there it is. Let's get rid of all the processing on this for the moment.
Eat a Peach Nebula.
That's right. Yeah, that's the Dumbbell Nebula right there.
Yeah.
Let's see if we can... Yes, it's too bright. Maybe if we do this. I'm gonna drop it down a little.
Not bad for bright moonlight.
I know. Drop it down even more.
Mark, would you excuse me for a moment, please?
Absolutely, sir. Go for it.
Right back.
Wow. So there we go. So that's the Dumbbell Nebula, Messier 27, in the constellation of Vulpecula. That's really pretty. You can see this beautiful greenish blue glow. That's actually the light of ionized oxygen. It's been ionized 2 times, so it's called a doubly ionized oxygen. And when the oxygen actually comes back into, when the oxygen atom, gives off the electrons, those electrons leave the atom and they come back in. And when they come back into the atom, they give off energy to get back into the atom, because they're always colliding with other things, these electrons, when they ionize and leave the atom. And when they come back in, they actually give off whatever's left of the energy to go back into an orbit or into the cloud, the energy level, the energy state. They give off light. And in oxygen, that particular characteristic light that is the dominant one in all the transitions the oxygen atom electrons make, that particular transition is the greenish blue that dominates the entire set of transitions that it makes. So we see that, and this red you see right here, this red is actually the light of hydrogen. That's hydrogen in air, or possibly neon. And so this guy right here has been the star in the middle is actually a white dwarf. And to the question from before about black dwarfs, if that white dwarf were to cool, it'll eventually become a black dwarf. And there is a time when it will be a black dwarf. All right. But and the time scale of the universe, I don't really know if there's any white dwarfs that have had time to actually cool to become full black dwarfs in that time. But that's a really cool nebula. This is a nebula that, to your eye, doesn't look like this. If you were to look at it with your eye, let me see if I can stop destroying my screen here. Let me see if I can bring this back. Let me see if I can... there we go. Put this up here. Okay. All right. So to check it out, let me first bring back our view here. All right. All right. So now, if we look, let me go into the live stack here for a minute. All right. Let's do this. Let's undo. Let's undo our view here. Okay, so in a telescope of moderate size, you might see something like this. However, the Dumbbell Nebula would not look green, and you wouldn't see the red. You would only see whitish or gray, because the way your eyes work, you have rods and cones. Remember, the rods are the black and white receptors in your eye. The cones are the color receptors. Well, when you look at a nebula like this, it looks bright here. Oh, that's because in a telescope it is. A telescope's a gigantic light bucket. Your eye is a tiny one. A telescope acquires signal and it doesn't let go of it, right? That's what cameras do, right? Well, your eye isn't like that. The eye has a fleeting moment where the photons come in and then they're gone. And then the next photons come in. So you don't get to take photographs or time exposures with your eye. With a camera you can. And so when you have enough pixels that come in, enough photons rather, that come into these pixels, as soon as you reach a certain threshold, you'll start to see the color. But you don't get that with your eyes. If a nebula is very, very bright, then you can see the color. But it's not the color you might expect. Sometimes you might see the green. Guess what? it's green that your eyes are most sensitive to. People think it's red, some people think it's blue, but it's green. Green is what your eyes are most sensitive to. And so you'll see, if you look at the Orion Nebula, which we're going to see in the coming months, the Orion Nebula is going to look greenish to your eye potentially from a dark sight and with a big telescope. You just need to get more light from that bucket into your eye. But again, you're limited by how much retained light intensity your eye can take. So without that retained intensity, the biggest light bucket in the world isn't going to show you the beautiful colors of a nebula the way we see them with a camera, which retains the color. It's building up the color. The first exposures that you take typically will look like faded color, and the color becomes more intense over time. And that's what we've been doing. That's what we do. We're making intense images over time, you know. So, but that's the Dumbbell Nebula. Really, really pretty. It's a favorite of all people that start out with astronomy. You know, it was mine. I looked through it a million times. I looked for it and found it. It was great. But once I started doing electronic astronomy, which is what this is, I, sad to say, and Daryl's going to shoot me, I haven't looked through an eyepiece in years. You know. And there's something to be said for looking through an eyepiece. You know.
Well, it's just, I mean, visual is what I do.
Mm-hmm.
And there's just an immediacy to it, the realness of it. You're not looking at something on a computer screen. You're looking at something, you know, real that's falling into your eye.
Mm-hmm. That's right. Yeah, and there's something very good about that, and there's something about that I think all people should get a chance to do. I certainly know that I loved looking through the eyepiece, but I got frustrated because I couldn't ever see those additional details with my telescope that I always wanted to see. You know. And Tara says,
yeah.
Apple core no more. Yeah. Yeah. So, that said, I'm pretty pleased with our view of the dumbbell tonight. And I will go on to the next beautiful object here on The Price is Right. Let's do our hyper process. All right. We looked at that, I think. Not tonight. Okay. Well, let's try that. Let's we're gonna go look at this guy right here. This one, that's right here. And away we go. Because it's so close, I'm just going to steer to it. Just go right on over to it. Starship coordinates. Okay, moving up a little bit. Mr. Scott, give it all you got, Mr. Scott. Aye, sir. We'll get there in a heartbeat. Center it up. go see if we're here. All right. So this cluster right here is associated with nebulous detail, but I don't see it yet, and neither do you. So what we're going to do is a time exposure, and we're going to expose it and see what we get. And in the time it takes me to set up the telescope to go to those proper amount of seconds, which will make 15 seconds, the telescope will have acquired a guide star and locked on it. So we can then do our exposure, and we will be perfectly able to see it after I get rid of the dumbbell in the buffer. And now we'll see something else. Alright. Let's go find out. Okay, there is the nebulous cloud inside this cluster. When the moon's not out, we don't have this kind of weird shadowing here. I'm kind of pushing the system here to show us. So, my apologies for that. You can see a dark lane right there. It'll become very clear once we have more exposures under our belt here. Because the more you expose, the more it stacks. The clearer the noise becomes, the less noise is in the image, the clearer the detail becomes. It's almost like you find it makes its way out. It makes its way out from the darkness. Cat's Eye Nebula hisses at the Pluto cluster. Yes, that's right, Kingus. That's cute. Nick Tesla says, yeah, the first time you look at something like Jupiter in an eyepiece, it changes you. It does. I remember taking my telescope out on the front lawn of my house that was 1 mile from here, which oddly is exactly 5,280 feet. I think you could plan that. And I remember taking the telescope out into the yard and looking at Jupiter, and I actually saw the scars on Jupiter from Comet Shoemaker-Levy that slammed into it. Yep. And they were black scars coming around Jupiter, and I watched all night as Jupiter rotated, and I actually saw the scars appearing on Jupiter. So it's really interesting to see that happen.
Yes, I did the same.
Yeah. Oh, Cypher too. Yeah, we all have floaters in our eyes too, and it shouldn't give you a hard time with eyepieces because your eye tends to suppress the bad parts of the vision, and that's something that I learned through astronomy and so forth. They don't go away, but you can move them around. How about that? Here's what I do. Go ahead, Daryl.
No, go ahead.
Okay. Because of the floaters in my eye, I found sometimes they're very annoying and they're in the way, right? But they're called floaters because they move. But you know what you can do is you can use gravity and inertial motion, I'll explain, to change their location and get them out of your main vision. And the way you do it is you look to like one side, and then you whip your head hard in one direction, and that inertial motion is causing the fluid in your eye to kind of swish a little. and the floater goes with it. And you do that enough times, so you go like this, and then you come back slow, and do it again. And now you're causing that vitreous humor to go like this and like this and like this. And little by little, the floater migrates out of the location, and you can watch it happen. And so that's how I keep my vision actually clear, is by just whipping the floaters out of the way. I think another way to do it is to get synthetic vitreous humor, to get synthetic liquid in your eyes. I don't understand why that is such a hard thing to do, to be honest. Basically like a transfusion. You have one needle in, one needle out. Of course, needle in your eye. There you go. That's the main reason. Can't do it while you're awake. And you pull fluid out as you're putting fluid in at the same rate. And over time, you're going to pull out the bad stuff, and in goes the good stuff. So I wonder just how that might work. Maybe donor vitreous that has been cleaned and filtered. Why is that so hard? There's not going to be rejection issues with it, because it's just a inert fluid in your eye. You could do the same probably with saline, but I'm not sure how the skin of the retina reacts to the vitreous and how they work in concert. So that's something for an OD, doctor to tell me. So that's just my thoughts. Crazy as they are. Okay. All right, let me just drop this down. I won't save this one because obviously we've got a lot of moonlight, but you can still see some of the dark lanes in the red of the nebula. That's pretty cool. That center brightening is an artifact in the camera that's corrected by something called a flat field. So that's just something we have to deal with. All right.
I have found with floaters, if you see them and you look away, don't move your head, but if you turn your vision just by moving your eye,
yeah,
and you do it, sharply, and then wait a few seconds and then slowly look back toward your object of interest, that you'll see the floater will shoot over the direction you look, and then you just try to sneak away from it to go back to what you're trying to focus on.
Yep. Same kind of process. I tend to whip my whole head because that actually swirls with more force than just moving your eye does. But moving your eye does do that as well. Yeah, I just prefer that. But folks that are younger don't have as many floaters, but some actually do. And it's maddening. All right, we're going to go to Measure 56 now. And this will be a different type of star cluster. And I have a few other things to look at too, Daryl, that I think people will like.
Sure.
Genghis, yeah, an auto tracker is very important, yeah. We call it auto guiding, and telescopes. This telescope is equipped with an auto guiding system that is really quite accurate. But every auto guider has its weird issues, and one of the weird issues is that if the telescope is seeking a star that is at the wall of the telescope and at the wall of the building and it can't see it, it starts hunting for it. And it's hard to make the telescope do the right thing after that, and that's a problem. But we do all right. Okay, so this is the object we just saw. This is Measure 52. It's a globular cluster. it's actually pretty far away, so it looks small. Compare it to the size of, say, Measure 13, which is literally, if you put your thumb out and touch your screen, it's about the size of your thumbnail, you know. But Measure 56 is, it's actually about 32,000 light years away, 32,600 light years away. And it's, most globulars are pretty far away because they're halo objects. They go around our galaxy and orbit the galaxy as a whole from outside the galaxy. Some go through the disk of the galaxy and they come up through the disk again. And they shed stars, they gain stars. So sometimes they do that, and it looks pretty wild. I want to see if we can. There must be a bigger one out here that we can see. I'm sure there is. We haven't looked at the Cygnus star cloud though. That's something to do. I've never looked at the cooling tower, and I don't know who named it that, but it's sort of a boring little cluster. There's nothing to it.
I thought you were going to look at M56.
I am. I've got it in there.
Oh.
See, it's right there.
Oh, okay.
But it's small.
Yeah.
So I'm trying to find something else to show folks as well.
Sure.
Let's see here. Yeah, we'll try this because this is cool. This is the crescent. And then while we're there, we'll check out some other things. The Crescent Nebula is one of Isabella's favorite things. She doesn't know it yet. She may know it. The Crescent Nebula is a C-shaped nebula, like the letter C. And it's shaped that way because the star that made it is actually a star called a Wolf-Rayet star. Now she understands why. It's one of her favorites. The Wolf-Rayet stars are stars that are very hot and have ejected their outer envelope of hydrogen gas, which really makes them rather unique. And after they do that, their outer environs, the area around them, is now filled with this outer expanding envelope of hydrogen gas, okay, primarily. And then when the hydrogen gas reaches the limit of the cavity carved out by the star's intense stellar wind, it gets slowed down radically, and when it slows down radically, it heats up tremendously, and the gas in that outflowing debris will actually ionize and then recombine with the atoms and give off light. And it's that recombination phase, not the ionization phase, which lets us see what's going on. It shows us the light. And so here, this star right here that we're looking at is the Wolf-Rayet star. This C-shaped thing right here, this is actually the Crescent Nebula. And we'll just sort of give it a little bit of time to show you that. I'll do a 15-second exposure and knock off the hyper process and just go to stack, and now you'll see it in a second. Oh yeah, Giggit, you got to see it in 1986. You saw Halley's Comet. Wow. Yeah.
Who, me?
No, Genghis.
Oh yeah.
I saw it.
Mira saw it. Genghis saw it. I saw it.
I saw it in Florida. I had a friend who decided he wanted to see it so bad that he was going to pay an astronomer to come with him to go see it, and so he paid my way the whole way. It was actually a good friend of mine. He told me, "You don't have to pay my way." He goes, "Nope, I'm going to pay. You know, I want your perfect. I want your input." Okay. So I went, and we actually looked at it, and we actually rented a plane, flew out. He did, and we flew over the Keys and found a quiet place to go with the telescope and set up where no one would bother us. You know, right? Where no one would bother us. Look at that. That's beautiful. Well, come to find out, we were on an isolated key, and we got out there, set up the telescope. You could only get to it from a very, very narrow coral road, which looked like you could fall off into the water at any time. And we're setting up there, and as I'm taking pictures, I feel something nibbling at my shoe. And I turn on the little red light, and it's a raccoon. And it's just like going, and they're really cute, you know? So I think that, it was really cool. Let me just answer this guy over on Twitch. We are streaming to Twitch and Facebook at the same time, by the way.
I mentioned in chat my best look at Halley. I think it was March 21st, if I remember right, 1986. It was the morning before sunrise, and I had driven out east of town, out into the plains quite a ways, and turned up onto some dark country road, and I was sitting out there in the dark. It was cloudy.
Okay.
And I was disappointed. I did not set up the telescope. So I just sat out there in the dark, and just before first light, the clouds broke and rolled back, and there was the comet. The tail was pointing to the west, you know, because the sun was in the east, and the tail was pointing away.
Wow.
The gas tail, and it was just to the left of the teapot. The handle of the teapot. The tail was 10 degrees long, maybe, about, you know, the width of my hand at arm's length, and it was overlaying the handle of the teapot and then jetting into the body of the teapot, and it was just drop dead gorgeous.
That's beautiful.
And I kept watching it. It kept moving towards the southwest, and at its closest, it was nearly to the southern horizon from here. Vera probably had a great look at it then down in Brazil. It was just above the southern horizon, and what was it? I've told this before. I actually accidentally caught, I was up on a hilltop in the mountains west of here, and I was trolling for the comet, you know, just doing a pan search, and I accidentally came across Centaurus A galaxy.
Wow.
Galaxy way, way down in the southern sky.
That's a beautiful galaxy. Actually, Centaurus A is right above, near Omega Centauri, which is actually one of the objects we want to check out. It's nearby. And it's the reason that we're putting the telescope on what's called a lifting column. It's actually going to be a rigid column, of metal. And the whole telescope, all 300, 400 pounds of it, are going to be lifted up in the air by this column and go up about 17 inches. And that's going to give us the look that we need to see all the way to near the horizon. No, we don't. As an astronomer, you don't ever look near the horizon. You look at around 35 or literally 35 degrees above the horizon typically, because otherwise you get kind of a bad view having to look through so much air, because, you know, it's a round planet. So when you're looking across the planet at something low to the horizon from your point of view over here, all the way through all this air here, it makes it very, very difficult and faint to see, and the objects lose some resolution because all that air is interfering with their image. So it's best not to have to deal with that, you know. But
well, sometimes you got to do what you got to do, and
we want to see it.
I know that night the difference in elevation between Centaurus A and Omega Centauri. Omega Centauri just breaks the horizon from here, and you cannot resolve it. but Centaurus A was just high enough, and the air up in the mountains was good enough that night that I actually resolved that sucker in the telescope.
Wow.
And it was small, but it was resolvable, and it looked a lot like the pictures did.
Centaurus A?
Yes.
Well, Centaurus A is actually about, from where we are, I think it's 25 degrees above the horizon, right at the lower limit of the current setup. We can actually see it. Omega Centauri we could not see yet, but once I add that lift system on the telescope, we are going to see it, and it's going to be beautiful. And we're gonna do that for SkyTour West and SkyTour East. So I'm thinking of getting the two piers very soon. I'm going to get one of them and experiment with it here. That telescope I showed you earlier behind me, which for those that might have just joined us, is this guy back here. That's our SkyTour East setup. That's going to go on one of those lifting piers. And I talked to a contractor today. He was here, and he may help us. He will help us hopefully build the new building. We outgrew the dome that we actually had. That you see, it looks pretty. It looks great with the nice red light inside, but we outgrew it. So sometimes you have to sacrifice pretty and cool and theatrical for practical. And so we did, and now we're going to have a better building with more capability, more room to do other things and add other things. I mean, we have a spectroscope that we have to put in there, a spectrometer that we're adding, and that's over there in the cabinet behind me on the right. And it's a little black box. You wouldn't really know much to see much about it, but it really is pretty. We're going to do 30 exposures, by the way, here. We're at 29 right now. And there's 30, so we're going to pause and save this stack right there. This is the Crescent Nebula right there, a Wolf-Rayet star's blown off outer atmospheres. And you might say, why isn't there one on this side? What's going on? Well, the star did throw material off, equally in all directions, but how come we don't see it? Well, there is some here, but it's actually kind of compressed a little bit. So what's happened is, this is an area of space where there's a lot of stuff, a lot of dense matter, okay? Black dust, lots of dust, gas. And when the star blows off its outer layers, that cavity it creates around it, as I told you, is affected by how much dust and stuff is out there that's not really that movable. So as that thing expands, as the blown off material expands, when it reaches the limit, however irregular in shape, that's when it's going to heat up. When it reaches it's like a truck plowing into a snowbank. Along the road, everything is clear. As soon as it hits a snowbank, it slows right down and stops, Well, that's what happens with the gas. It slows right down, but it heats up. And when a truck hits a snowbank, the snow heats up and it melts. Okay, so you get a lot of water associated with it with an impact like that. Rapid impacts generate heat. So impacts of the gas on other gas molecules or dust will generate heat, and that's why the gas glows like it does. All right, because it's ionized by this heat, and then and there's also the Wolf-Rayet star in the middle, which is ionizing the gas as well. So it's very, very hot, one of the hottest stars there are. So it's ionizing the gas all the way out on top of it. So as snow plows into the interstellar medium, that causes it to get slowed down and heat up as well. And then the Wolf-Rayet star's own intrinsic heat will ionize and cause the glow. So even close in, you're going to see a glow around the Wolf-Rayet star. All right, but that cavity it creates is a cavity that will also cause this material to slow down and stop and change its shape, like we see here. It changes the shape to the different shapes. It's not just a sphere. It's being warped and twisted by the interstellar medium. So it's actually a pretty interesting process that happens there.
Is the Wolf-Rayet star that brightest one inside the curve of the crescent?
Right there.
Yeah.
I confirmed that by going on a NASA portal site and checked out this location and looked at the specific star designation that was given as the Wolf-Rayet star, and that's the star that it was. All right, it's kind of interesting. So it's bright. Again, like I said, they're very hot. ERRT Radio is here. Hi there, Ronald. How are you? Thanks, Bonnie. The spectroscope's going to be really cool. You'll be able to see what stars are made of with this. It really works well. I've been able to get some very, very high resolution spectra just testing it. So it's pretty cool. OG Skywatch, how are you? Snowbanks on bridges can cause cars to fly off. Yeah, well, that's a fun fact. Just not for someone in the car. Hey there, Amal. How are you? Skunk Ape. Now, there is no dumb question. That's the thing that I always try to tell people. You know, there's no dumb questions when it comes to astronomy. You should hear some of the questions. You would think that there are people who are like embarrassed to ask them. It's like, stop. You shouldn't be embarrassed to ask questions. Isabella, thank you. Thank you. Isabella's a really good artist and a wonderful image processor. She does wonders with her art. You need artwork done, actually, and you know she's the one to go to. She's the one to go to. This day and age, Sofia, Bulgaria is not far away anymore. You could get her to do work for you if you need it. Check it out. Look at these nebulae around this crescent nebula. Okay, this is beautiful. We're gonna stop. I said I was gonna stop, which I did, and I think I saved it as exactly as seen, but I'm gonna do it again anyway. Okay, and we'll see it up here. There we go. Okay, and now we'll clear that and go to the next thing. What is the thing we're gonna see? I don't know. We'll find out. All right. And I want to thank you guys for hanging out tonight with us. It's really a lot of fun. We enjoy your company. Daryl, I know, really enjoys it. I enjoy it. Daryl's out in Colorado. I'm in Connecticut. And we're running the telescope out in Arizona. I mean, we're a nationwide effort here. You know? Okay.
This is sort of like 2001: A Space Odyssey when you think about it.
Yeah.
We're living in the future.
Yeah, it's true, isn't it? It's really
telescopes in Arizona. You're in Connecticut. I'm in Colorado.
Yeah.
Isabella's in Bulgaria. We had a guy from India here earlier.
Yeah, and of course, Vera Lucia Campos is in Brazil. I mean, AS in Brasilia. You know, I mean, it's just great. You know, it is a definite todo el mundo. You know, all the world. You know, we have people from all over the world who join us, and it's really, really pretty. And to look at the night sky with all these people. Hey there, Ghost Jazz Kill. How are you? Good to see you, man. Thank you for coming in.
What if you were to frame that dark area, that dark blob in that reddish zone just to the right of your field there?
This here?
Yeah. And just do an exposure and see what happens.
Well, isn't that the North America?
Is it? Oh,
yeah,
duh.
Yeah.
Okay.
Yeah. So we know what would happen. But you know what? We can do it. I'll tell you what.
Yeah, never mind.
No, don't say never mind. Let's find out. We have a nearly full moon. Let's try and see if we can do it, Daryl. That's a good idea.
Sure.
I would like to see the Pink Pillow Nebula at some point. It's another planetary. It's magnitude 8, which means that it's relatively bright, but I'd like to see what it looks like.
Sure.
It's like the Green Rectangle Nebula, it's called. Now we're going to Deneb, which is the brightest star in the constellation Cygnus. And this star is going to be our guide star to the location that is in the North American Nebula that we're going to try. Amal, that's funny. Bulgaria, Philadelphia, same thing. And Lucy's in the sky with a diamond. I guess that's true, you know. So here we go. And you'll see, even with the moonlight, you'll see that there's a nebula right here. You can see it. All right, so we're going to take an exposure right here. Because we have that star dead center that that I'll show you one more time. All right. This is not that star, is it? No. I'm going to go here. This is the star that we're centered on right now. Okay, it's in the middle here. It's a little guy. Actually, that's probably... Well, we're going to see it in the upper left. We'll see it here. We'll try it. Why not? It's just a little location. This is, like I said, the North American Nebula. Okay, here you can see this is Mexico. This is Florida. And then this here is the Pelican Nebula. We have another piece of it that we just never really look at right here, Daryl. So we should look at that too.
Sure.
Yeah, so we'll do that. All right. We are good. So now we're going to come in here and do this. This is, you know what? Because of the filters that we're using, this really is turning out to be a rather good night, even with the moon. But I'm not pushing the exposure. This is going to be the biggest push of the exposure here, going to 20 seconds to see what happens here. But let's go. Oh, you want to see an RR Lyra? RR Lyra, you know, that's a namesake for the RR Lyra variable stars. Okay, we're almost done with the first exposure. Let's see how it looks. We may have to process a little bit. Oh, we start to see some good stuff here. Yeah, well, there it is, and we gotta actually. Well, that's the area you want to see, Daryl. But you know, we'll check it out here.
I feel stupid for not recognizing it on Stellaria.
No, there's no stupidity. I mean, how many times have we both thought we were looking at something new, and it turns out it's just a different perspective on the same old stuff we saw?
Yeah.
That's not a big deal. I have no problem with that.
Well, do you want to compose the shot a bit?
Well, let's first see what it looks like. Now we have 3 stacked. Look at it. There's a Cygnus wall. Yeah. That's beautiful.
And Pelican's head's kind of going out the top of the field.
Yeah, but we want to look down here, though, to see the rest of this down here, right?
Sure.
So I'm going to clear this, and you're going to say, wait, that's such a beautiful shot. Yeah, I know. But don't worry. We'll bring it back. We'll be back. What I'm going to do now is I'm going to go back to our 1-second shots. We're going to compose a different type of shot for this. We're going to come back to 20 seconds shortly. But right now, what I'm going to do is take us down just a little bit more. Okay, this here is, that's right there is that Cygnus wall I mentioned. This is the dark void, and then the Pelican is up in here. But we want to see what's down here. There's more down here that we've not looked at. So I want to do that. So we're going to move it up and check it out. Get him up and move him out.
Rawhide.
Yeah. All right, so there we go. So now in the time it takes me to actually set this up and set the exposure time to 20 seconds and do that. In that time, we will have captured our guide star. And now we can come back in, do a live stack. I'm selecting live stack from the menu that you can't see in your view right now. And then we're going to be able to capture this box down here. You can see this little progress bar. This takes us to the full extent. Right? And then 20 seconds later, kaboom, we get an image. And there we go. Oh, there's even more. I should go even further south. Yeah, we're going to go even further south. All right, we'll pause this for now. Clear this. And then come back here.
Might be a good subject to build a mosaic of.
Yeah, that's exactly what I was thinking. And when the moon is gone, I might do that before we lose it entirely. All right, so now let's go. Okay, first of all, let's get rid of this for now. clear it later. All right. Okay, so we're at 1 second now. And let's do this. And move south a little bit more. All right, one more shot. Okay, that should put that chunk right here. Okay, here we go. And we're going to do 20 seconds again. For nearly a full moon, for you to see it like this, guys, it's really quite astonishing. You know, the filters can get rid of nearly all the moonlit problems. I say nearly because not all, but 20 seconds coming up. Down here, the green progress bar shows us the extent of our exposure, and we're about to see this beautiful first shot, and boom, there it is. Boom, there it is. That's the rest of the Cygnus wall from that upper part, and this lower part is what we want to take a picture of. So this is for reference so we can see it. It looks kind of modeled right here. That's because of the fact that we are stacking, and right now only one exposure has been taken, so it kind of looks terrible here, you know. That will change.
We've been going a while. You might want to check your focus.
Yeah, I think that that's true.
Looks a little soft.
It does. I was thinking that earlier, but I didn't want to take us away from what we're doing. But
I'm sorry.
no, it's fine. It's fine. That's a good thing. Our focus system is one that is electronic. We have tens of thousands of different steps. Okay, you'll notice where it is now, Daryl. It's actually not anywhere from what we did before.
Yeah.
I was playing with it yesterday, actually, just to get the focus right. So what I'll do is we're going to end the live stack here. We're going to still go further south because I want to get this up in the view more. And we're going to end the live stack here at all entirely. And then we're going to come back here and do 1 second exposures again, because we're now going to focus the telescope, and you'll get to see that up close. And you'll also see the problem with the telescope. We actually have issues with the collimation, as I told you, the way that alignment is that Susan Woodcarver was explaining earlier and talking about, asking questions about. But what we're going to do now is I'm going to zoom in a little bit. Let's say 50% to a star kind of in the middle. Right? And let me see if I can do without that hyper processing.
Happy birthday, Lane.
Lane? It's your birthday?
Yeah, with a Daisy and Zoe. Happy birthday, Lane.
Hey, happy birthday, Lane. Wow. You're October 20th. I'm October 17th. I just had a birthday. Haha. Wonderful. Very happy to see that. All right. Okay. You can see the collimation error here with the telescope. These should be points, not dots with little, halos around them. That's part of our issue. Oh yeah, I didn't see if Amal said something. Yeah, as the temperature changes, Amal, we have to refocus. And this focuser we're using can actually do that. It changes with temperature, and once I train it, we'll be able to get that to work. Right now you can see the stars are getting a little bit smaller, and it's getting a little bit better. But then it's going to get to a certain point and it's not going to get any better because of the problem with that collimation I told you about. Okay, 5291. Let's try this, which should be way out. Okay, not so bad. We'll try this, which should be what we had, and that. I'll actually try this one. Trying different focus settings.
Yeah, if I remember right, that one worked well the other night.
Yeah.
A little later in the evening.
Yeah. It looks like it's doing a little better right now. Alright, looks good, huh? So we're going to leave that one. Once I get this collimation error fixed, then we're going to have star points and not weird little shapes to the stars. But now when I pull out of here, our stars are going to be more round in general. And we'll go here and look at this. Okay, and now I'm going to go down some more.
When's your birthday, Mark?
It was October 17th.
Oh, hell, you should have said 2 days ago. Belated happy birthday to you.
Oh, thank you. Now, let's see. Oh, thank you, Vera. Did I comment Leonard? Yeah. If we could see it, we will look for it. We will show it. We actually did comment Neowise, and I actually took images of it over time and then put it together into a moving picture. Over 45 minutes, you could actually watch it move through the sky. It was really, really pretty. Comets, when people think the universe is immovable, immutable, doesn't change, we can clearly show that it does. You know, so it's pretty cool. All right. Now we're going to do a 20-second exposure and get rid of our hyper processing state and come back to our live stacking. And I'll get rid of the previous buffer, which you see there. All right, and all of this will be moved up and it'll be more in focus now. I haven't trained the focus, Daryl. Hi there, Mr. Spiritus. I didn't see you there. Okay, this will work. I haven't trained the focus, Daryl, because without the collimation being perfect, it's just like there's no point. I'll just do it manually until we're ready.
I hear you.
Yeah. Okay, so the modeling here that you see is going to go away. We're going to catch some more detail in here. Look, there's even more down here. It's almost like I want this. I didn't want this. I want to get this here, and so I'm holding here just for now. And that's not actually the best view of this. We might be able to do better here.
My birthday is near Christmas.
Is it?
Yeah.
When is it?
23rd.
Oh man, you got ripped off as a kid.
Oh yeah. Oh, they always told us, well, you can have it now or you can wait 2 days. And they always cut us slack though. They let us open something for our birthday. And, it was traditional in our family. We opened presents on Christmas Eve evening. So we really just had to wait Monday anyway. But they let us open something early.
That's cool. My oldest son's birthday is December 21st. The winter solstice, I think. Oh, Bonnie, you watched Neowise with us? James Dugan, hey, how's it going down in Australia? Welcome. Good to see you. Oh, and thanks, James. That's very kind. Thank you for the well wishes. With a nearly full moon, we're capturing this faint nebula here. There's a lot of detail in here that I want to record, so we're checking it out. I think it's pretty cool.
And I want what I always want every year.
A big
a pony and a magic flying belt and a green Orion slave girl from Star Trek.
I never pegged you for someone who's into slavery, Daryl.
Well, hey, it's a green Orion slave girl, man, you know.
Yeah, I know. Everybody liked the green Orion slave girl from Star Trek.
Fred actually found one and gave it to me for Christmas years ago.
Really, it was like a stuffed doll or something?
Little plastic, huh?
Like, oh, okay, like a little plastic figure.
It's a little plastic figurine. Cartoonish, but it's really cute.
That's cool. Oh, Vera, thank you.
Vera.
That's very kind. Thank you so much. Wow. Yeah, we have Raymond, we have Isabella, and now Vera. Gosh, you guys are wonderful. Thank you. Really enjoy your company anyway. This is wonderful. All right.
The magic flying belt is a reference to a very bratty nephew.
Oh, really?
Yeah, when he was a little kid, he was a little monster. He was spoiled rotten. And one Christmas...
sounds like me.
When I was a kid, but he was much younger kid. He got everything a kid could ever want, most kids could ever want for Christmas.
Yeah.
But he threw a fit because he didn't get the one thing he really wanted. It must have been some Saturday morning kids show he was watching.
Oh.
He saw a magic flying belt on some kids show.
A magic flying belt.
Yeah, and by golly,
Jeez.
that's what he wanted for Christmas. And he had a conniption when he didn't get it. He threw a fit. And ever since, I've said, I want a magic flying belt for Christmas.
Hey there, Kathy. How are you? Kathy Prunasek is here with us. How are you doing? Haven't seen you in a while. I understand. Well, thank you for coming. I'm so glad you were here. I know we start later because, again, I'm not doing the East Coast side. Now I'm doing the West Coast side. East Coast is coming. We got the East Coast telescope behind me, as I showed before. And I'm refurbishing it, and we're building a new building. We've outgrown the old one. And we sold it, and now we're building a new one with a lifting pier that's going to lift the telescope up and down, same as our Arizona we're doing. So we're going to have a beautiful capability coming up very soon. Looking very forward to it. But thanks for stopping by, Kathy. You have a good night. Kathy's always been very kind to us. Yeah, very nice to see her.
Mark, excuse me again for a moment, please.
Okay. So I'm just trying to get a little detail out of here. You can hear the noise in Daryl's mic. Yeah, so I'll cut back on this again and bring it back to what it was so that we can coax the data out over time here. That's really pretty. Now, if we actually come back and we add our hyper processing here, it's going to add a whole new dimension. It might not be that good, but let's find out. It'll get brighter, but we might also get more detail. Yeah, not so much, not in this case. So it's a little different. Well, let's wait. Let's find out. Let me see if I can push that even more. I can push it even more. There we go. Yeah, see, it gets way too bright. But what you can see is you can see all these subtle details in here, and you don't want to keep it that bright, obviously. But you can see the subtle details, so it gives you something to aim for. You see what I mean? It tells us where we want to go. Are you guys having a good time? You know, I know it's sort of one way, but you can tell me in the chat. And by the way, make sure that you do give me a thumbs up on this video, if you would. I think that's probably a really, very, very helpful for us to do. We just passed 5,300 subscribers, and I'm very happy and humbled that you guys want to make this part of your nighttime routine. But who doesn't like astronomy? Well, there's a few people that don't like astronomy, but there are a lot of people that just love what astronomy means to them. William Shatner went up in space, not in space, he went up with the Blue Origin on a ship that looks rather oddly shaped, and I thought it was kind of funny. But I mean, it is an elevator. It just goes up and it comes down. It certainly doesn't get any. You can't even say. You can say going to space because it passes something called the Kármán line, which is 62 miles straight up, or 330,000 feet. And that's just a worldwide definition that at this point, spacecraft propulsion is in play over aircraft propulsion. So that's what it's about. Oh, Greggy Gilgan, you're also in Australia. I did not know that. You're in with James Dugan, who's also in Australia, who's here as well. Greggy, tell me where you are in Australia. So when Shatner went up in space, it was really funny because he came down and he was subject to something called the overview effect. You see the Earth from above. There's no politics, no borders, and you're above the sunrises and above the sunsets. And you are truly separate from the Earth for the first time. Or as Shatner might say, I was separate from the Earth. Above me is death, and below me, life, and everything we've come to know. I mean, and so he was actually very taken by it, but he actually expressed it kind of in an interesting way. And I work with Douglas Trumbull, who some of you know. He's a Academy Award-winning visual effects guy, and Doug and I work together. In fact, I'm going to go up there tomorrow or the next day because he's actually giving me a collection of all of his UFO books that he's amassed over the years. I'm like, I'm amazed. But Doug was working on a project called the Overview Effect with NASA and other folks. And so his take, none of us has been up in space to see this, but wouldn't it be something if he could get to go up and I could get to go up in the Blue Origin little bottle that shoots up into space. You just peek above and say, oh, look at the Earth is round, and then come down. There was a funny meme out there that said, it shows William Shatner, and he says, the Earth isn't flat. Take it from me. Been there. I've seen it. He can actually say it now, which I thought was pretty cool. There's a lot of other memes that show William Shatner as Captain Kirk staring out a window into space on the Enterprise, and then shows him literally staring out the window of the Blue Origin spacecraft. And see them together, one's fiction, one's real. It's kind of cool. And I want to say something about this too, because we say, and this is still stacking, so we're cool. People say, well, space is for the rich. And I know, Isabella, you expressed some commentary on this as well. And all the things that you said and all the things that other people say are true. Space is for the rich. When are we going to get it? Well, it's in the process of being normalized for the rest of humanity. Don't forget, when the first cars came out, they were for the rich. Only rich people had radios. The first televisions, only the most wealthy could afford a television. Okay, and then as competition and prices dropped, over time, as competition occurred and prices dropped, everyone could own a radio. Everyone could own a television. Everyone had, a car. And cell phones were originally just for the wealthy who could afford that gigantic Radio Shack case you put over your shoulder and afford the bill. And now they're for everybody, in a variety of ways that do things that William Shatner, as Kirk, would say, I want one of those, and he would dump the communicator. So space travel's in the process of being normalized. It just happens that all those things I talked about, cars, phones, and the other things that used to be for the rich, everybody has those now because it's been fully normalized. And it's been around ever since most of you have been alive. So space travel is that new thing that's still being normalized, okay? Even owning an airplane is in the process of being normalized. They're selling computer-controlled drone systems to fly one person or two in the next year or so, and they're going to cost the cost of a luxury car. Yes, no, I won't want one. I will not want to pay that kind of money for such a thing. But there are people that can and will. And then eventually the price is going to drop even more, and you'll be able to buy one on Amazon. Interesting. A drone, one-person drone delivered by drone? Oh. Or they deliver the drone itself is the delivery. Oh my gosh, my head is going to explode. But you see what I'm getting at. So I know that there's a lot of give and take on this argument. But space is for the rich right now. But don't forget, space used to be only for the Air Force pilots. Space only used to be for the military people that were in the military. You couldn't fly if you weren't military. Then, with the advent of the space shuttle, the need for science in outer space, well, military guys are generally not scientists. So they had to fly payload specialists on the space shuttle, and they had to fly people that knew science. And then the space station goes up, and now they have scientists in shirt sleeves. Remember, everybody wore a spacesuit in the beginning, but space has been normalized in the scientific community as well as the general community. It's in the process of being fully normalized for everyday exposure and everyday, what's the word? Everyday exposure. So that's something that is already in the process of happening. But just because it's happening now doesn't mean it's only for one category of people. That's how it starts. That's how it starts. Mark my words.
Remember how one of the selling points for the shuttle was it was going to reduce the cost of getting a pound to orbit?
Yeah, I mean, each launch was $22 million. That was the idea, right? But they didn't figure the deaths of people and re-entry destruction and things like that.
Well, my point is just look at SpaceX now and Elon Musk. I mean, he is getting the price of a pound to orbit down.
Yes, he is. He is, and that's why his Starship program has been chosen for the NASA Return to the Moon missions. Yeah. Genghis mentions, as Greggy did, that Shatner is talking to Bezos, and Bezos, ever the CEO, is paying attention only a small amount to Shatner, and Shatner is really being profound, really moved to tears actually, and Bezos at one point couldn't be bothered. He turned away and spraying champagne around, and Shatner just didn't know what to say, so he turns to the woman standing next to him, looks at the camera, and he starts talking. That was kind of rude. Yeah, I totally agree. Not kind of. It was rude. It was the wrong thing to do. So I did not like that. And, Bezos went down a few steps in rank for me. It's like you've been demoted two steps in rank. Return to your post. Remember that?
Well,
balance of terror.
I would have to think, Shatner isn't going to get out of bed unless there's a paycheck in it. I assumed he was paid to do that.
I don't think he was.
I have heard it at least he got the ride for free.
I believe he was given the ride. I don't think you had to pay. The other two guys on the ship that you didn't hear anything about were the paying customers.
Yeah.
I don't think
a funny
Shatner.
picture earlier today of Shatner in an Amazon warehouse pitching boxes. It was funny that he was earning his keep.
He earning his keep. That's funny. That's funny. Okay, we did 13 exposures of this thing. We're gonna go a little longer here. Wait, I didn't stop it, did I? Oh, I did. Stupid me. I can't believe I did that. I apologize. Okay. I wonder why I wasn't getting any better rendering. Okay, I must have hit pause by accident. My apology. Yeah, James, I'm with you. You know, I know how drones operate. I know how they get confused sometimes. And I know some of the disasters that have occurred with my drones. I've had drones for many, many years. Actually, I was one of the first people in the state of Connecticut in the United States to actually dive headlong into drones. In fact, I was written up in magazines and all kinds of stuff. They were here doing stories on what I was doing because I was coming up with a whole search and rescue system for using drones with infrared systems to rescue lost children, find lost children. And that, luckily, that started being taken on by everybody else. And so now that's not a thing because everybody's doing it. And I don't care. I think that's great. I don't care who does it as long as it gets done. You know, it can save a life. I'm in. You know, I don't care who it is as long as it gets done. Yeah. Tara says, thought the moon was getting brighter. You know, if the moon's getting brighter, it means the sun's getting brighter. And in fact, the sun is sort of entering middle age soon. It's not really quite there. It's actually longer than 10 billion years. They always say 10 billion years, and it's at 5 now. But, you know, it's at 4.6, and it might go 11 or 12, you see? So we're not quite to middle age yet with the sun. So the sun has some brightness changes to go through still. But certainly within a human lifetime, you don't notice the moon getting any brighter. I know there were some people that were trying to sell their religion by saying, the moon's getting brighter now, the sun is going bad, something's going to happen. Well, it's the same kind of people that says Nibiru's coming too. Okay? And to me, that's disingenuous to state things as fact when you have absolutely no clue if it's true or not. And I have no mercy on those people. I really don't. You know?
There's one born every minute.
Yeah. That Barnum and Bailey.
Money.
What's that?
I said send money.
Oh, yeah.
I have CRS. Only you can help. Send money, please. Lots of money.
You know, I don't know, for those of you listening, if you know James Randi, the former, he was a magician. I think he passed now. But I had dinner with James at a restaurant. I've been a magician since I was in 7th grade. And James came to Connecticut to do a talk at a location, a science center, actually, where I was working. And he saw me, we talked, and invited him to come out. And he came out with a whole bunch of us friends that came to see it, magicians, his talk. And we went to a restaurant called the Pie Plate in Avon, Connecticut. We arrived at 6 p.m., okay? And his talk was late afternoon. And we didn't leave until 3 a.m. The restaurant closed at 10, and we stayed, and the restaurant people started to crowd around and sit with us because we were all doing magic and stuff, and James was showing these really cool things. Oh, my gosh. You know, and he was talking about things he didn't talk about publicly, which was the way he literally took people that were trying to claim they were psychic, who were lying to you, and just disastrously and embarrassingly throw them under the bus very publicly. And one of them I remember was this one reverend, which he's published, he's talked about this, Peter Popov. Remember that Popov controversy? Do you remember that at all, Daryl?
Vaguely. I remember the name.
Well, he was having people, when they come in, write down information and what they want prayed for on this little thing. It was a revival tent type thing. And, the people that believe in that, how dare you, how dare you affect their belief systems with your lies? The guy actually had his wife speaking to him through an earpiece, reading the papers to him. And then he would say, I'm getting this feeling someone out there needs a prayer for her brother Bob. And this woman cries, oh my God, because she thinks that's private information that she's giving, and the prayer is going to the heavens above. But Popov was lying, and his wife, and what Randy did was he tapped into the frequency that the wife was using. And he captured all the things that she was saying, and he played it back on national TV. And of course, Popov was destroyed and gone. What happened to the money? Well, the money never went anywhere. It stayed with him. So, I just thought that's I can't handle people that do that kind of malicious lie. That is just awful. I'd love to rip those people out, just tear them out, and just Anyway, sorry. That's a tangent, isn't it?
Well, interesting story. I imagine having dinner with the amazing Randy must have been. You ever see the movie My Dinner with Andre?
Oh yeah, it was a long time ago. I saw that.
Must have been like that.
Yeah, it was fun because James Randi and I had conversed before, and other magicians that we conversed with them. The guy was very personable. He knew that we were magicians, and he knew that we liked what he was doing. So we went. I invited him to dinner, and we went out. And he's a short little guy. He was very, very short. He's like probably 5'2". Very, very thin. His beard was the biggest thing about him. He had this big long beard and bald head and gray hair. It's really, really funny. But he was a very entertaining individual, and he had a lot of stories to tell. I think the flaw in James Randi is that he didn't believe that any of that stuff was possible. Any of the psychic stuff was possible. Yet I know that it is. And just I'll say to the chat, for instance, the way is every single person in this chat, every single one to a letter, has had the situation in their life, and I guarantee it's true. And you can say, right? Every single person has had the case where they have thought of a friend they haven't talked to in many, many years, perhaps a decade or more. And as soon as they think of that person calls on the phone. And science would have you believe that's a coincidence. Not with every hand that's up now. Not with everybody who's listening going, oh my gosh, that's happened to me many times. It's not a coincidence. It's science undiscovered. It's today's paranormal is tomorrow's science, possibly. Not necessarily, but possibly. This thing, however, is. And I think I know how it's working. And this goes back to when I was in a coma and was a quadriplegic 6 years ago, okay? In a coma, I was wide awake, and I was able to get in touch with parts of my mind, because all I had was just a head, I was nothing more than a head. And I remember being able to connect with parts of me that I've never been able to connect with since. And I realized there's so much more going on inside our heads, that we used to be able to connect to. Well, anyway, the bottom line is that I think that what's happening is when we have that feeling that someone that we haven't talked to, we think of them and they call. I think I know what it is. Yes, OG Skywatch says synchronicity. Yeah, another word for synchronicity is quantum entanglement. See, quantum entanglement works, as far as we know, at the atomic level with electrons of a certain spin nature. Okay, that's how we see it. But I think that because our brains are made of the same material as organic creatures, I think that there's quantum entanglement at the brainular level. That's a word I made up. Right? And so when we think about someone, it's as if we're sending out a signal that we have yet to be able to figure out. They get it, and one of the two people decides they're going to call the other, maybe. And maybe you don't. But if you think about that, and you really strongly think about that, and then somebody calls you that you were thinking about, it's like, wow, I was just thinking about you. Every one of you knows that's happened to all of you. Well, it's a thing that has to do with this quantum entanglement at the brain level. It's an organic quantum entanglement at a much higher level than just electrons. And I've talked to people about it, and I said, look, I'm a science guy. I know I only believe, I know that I believe in addition to what we understand factually, I don't only believe in that. I believe that there's other things we haven't yet found, and this is one of those things that we haven't yet nailed down. I mean, if we can't figure out what gravity actually is, what makes you think we can figure out what quantum entanglement at all the various levels is? If we can't figure out how the brain actually works, which we haven't, right? I had doctors tell me I'd never see again. I see. I have 98.8% of my vision back. I see. Okay? I rerouted in my brain, everything, to be able to see again. My vision center's gone. I had all these clots that went to my brain and literally blew up in the visual center. My visual cortex is gone. But I have no problem seeing because I rerouted it. And I was able to do that because our brains are plastic. We can move stuff. We just don't know it. But when you're as desperate as I was to be able to see again, you figure out how to make it happen. I know it works. And there's other people that I've talked to about this who've actually been helped by this, and it works. It works. You know? Okay.
You ever see the show Pet Psychic? It was on Animal Planet a long time ago.
I heard of it. Yes, I remember it. I never brought myself to watch it because I haven't figured out in my head if I believe dogs have a conscious thought process like we do yet, or cats or whatever.
Oh, I love that show. I forget her name, the Pet Psychic. She, people would come on with their pet, their dog or whatever, and she would tell them what was on the pet's mind, and often it was, your dog wants ice cream. And the camera would cut to the dog, and the dog is sitting there smiling and his tongue's hanging out, and he goes, yeah, ice cream, I want ice cream.
Oh my God.
That show is so funny.
That's because you're a dog person like I am. I mean, my dingo is just a stunning little animal, and today another dog like Dingo was here. Dingo's an Australian cattle dog, and this other dog's an Australian cattle dog. And, if dogs could ever show personality, this dog does. Okay, Tilly and Dingo got along, but I had to watch Tilly. Tilly was the other Australian cattle dog. Tilly and Dingo got along to the point where, Tilly being 2 years old, Dingo being 10, Dingo didn't want to be bothered by Tilly all the time, but Tilly is all over her. And Dingo would give you the occasional, "Rah, rah, rah, stop it," Well, today, Tilly comes over again because the guy putting in the door is one of Tilly's owner. And Tilly comes in the house, and Tilly's all happy, sees Dingo. Dingo! You can almost see it, and she goes over to Dingo, and Dingo looks at me and goes, seriously? And literally, if a dog could ever look at you like this, it was Dingo. She had that look. I took a photograph of it. She looked at me like, are you kidding me? This thing again? I never saw a dog that had that look before, but she showed me contempt. She did not want this dog in the house. Like, really? And like, oh. And she just turned her head like, oh, here we go again. And when Tilly left, Dingo just went, "Rrr." And that was her saying, good riddance, like, get out of my house. I don't know. She was too much energy for Dingo. But the cat walking in the driveway yesterday, was not too much energy for Dingo. She saw that cat, and I opened the door not seeing it, and she bolted out the door and ran all the way down the driveway at top speed, that 10-year-old mutt. And the cat ran into the woods next to the house, and she didn't go into the woods because there's other things in the woods like bears. So she came back to the house, trotting up, happy as you can be, you know. So yeah, that was sort of a long diversion, guys. I'm sorry. But this is the southern location, the southern North American nebula, the area down below where we normally take pictures. This is going to make some pretty pictures later. We'll go back to this Darrow, I think, after the moon is gone too. We'll have less of this blue here. This can all be removed later digitally. But I think it's actually kind of cool. I think I saved all these. Okay. Yeah, there's lots of additional nebula in here. Very cool. All right. Let's clear this and get out of the stack. And Tara, I still see her here with us. Thank you. Nice to see you. Of course, you are 3 hours behind me. You're actually at 10 p.m. versus 1 a.m. like I am. Yeah, good cat chase is always worth the... Well, she doesn't go after the cats to kill them. You know, she's never done that. What she does is she chases bunnies and things like that, and then she stops dead in front of them and just stomps around. Boom, 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 boom. She wants to play. Every time I take her to this large 1,000-acre preserve that I take her for a walk in sometimes, every time we've gone, we see a bear. And I don't know why. People have been there who say, I've never seen a bear when I've come here. We see a bear every time. You know, maybe I'm just there at the right time. Maybe animals just love, especially bears like me, I don't know, or like dingo. Either way, bears are just very, very prevalent there. She sees the bear. What does she do? First thing she does, bear, yeah, friend, I gotta have fun. And she goes up to the bear, stomps her little feet in front of the bear. Okay, this is a North American black bear. We're not talking a small creature here. We're talking a very big animal. And this, I'm gonna move to another object. And this bear just sort of lumbers off, and she's like, you can almost hear her, wait for me, no, wait, come back, let's play. And the bear starts to run, and she starts running, thinking the bear is playing. She chases the bear deep into the woods, and I hear crunch, crack, snap. You know, I hear the branches under the bear who's running for its life, and I'm thinking, oh man, this bear will never come back now. You know, this poor thing. And then she comes running back, and I swear I see disappointment on her face. She comes back like this. Oh, it ran away. I want to play. You know. So she's funny. We're going to the Pink Pillow Nebula now, guys. I've never seen this. I even don't know what to expect, to be honest. So we're going to find out, aren't we? Okay.
My dog, Bub. B-U-B, Bub.
Bub.
He weighed 110 pounds. He was half Chow, half German Shepherd on his father's side.
Wow.
And half Chow Border Collie on his mom's side. He's a great, big, handsome dog.
Wow.
He threw a fit one night. He heard me leave. He was in the backyard behind the cedar fence, and I left via the front door and walked across the street to the neighbor's house. And he started barking because, you know, he didn't want me to go somewhere without him. And I told him to hush, and I went to the neighbors, and we hung out a while. And it came time to leave, time to go back home.
Yeah.
And I got up and opened the front door, and there was Bub. He had jumped the fence and was waiting for me just inside the front door. I opened the door, and he came in like a rocket. And the neighbor had a cat.
Uh-oh.
And Bub saw the cat, and the cat saw Bub simultaneously. And the cat took off like a rocket and ran down the hall. and all the doors were closed at the end of the hall. And
Yeah.
Bub cornered the cat, and oh my God, I was afraid, Bub was going to kill the cat or
The
something.
blood was gonna
That's
fly.
certainly what the cat thought. The cat sat there just frozen in fear and shrank
Yeah.
back. And Bub charged the cat, came right up to him, and he sat down and very calmly stuck his front paw out, and like he was trying to shake hands with the cat, and he
That's
was
cool.
trying to make friends with the cat.
That's
And the
very
cat didn't
cool.
know what to say. Neighbor freaked out.
Wow. Well, the pink pillow, I wonder if it's this right here.
It's pink and it looks sort of pillow-like.
Yeah, that's probably it. We'll just do a couple more of this and just see what we got. Can see some dark nebula up here, but that looks like the pink pillow nebula. Very cool.
And my other dog, Cinco the Samoyed, I took him back home to Missouri on summer vacation once,
Yeah.
going to stay with my mom for a week or so. Uh, we went in, and Cinco, he was a Samoyed, big fluffy white dog, and
Right.
uh, well, we hung out a while, and it was hot in summertime, and we were indoors where it was nice and cool. Uh, my mom had a cat, and I had forgotten all about it. And the cat came to the back door, and she opened the door, and the cat came in. The cat saw Cinco, and Cinco saw the cat simultaneously. Cinco hated cats, okay? He took off like a shot. He went after the cat, and the cat turned around and exited out the back door. And my mom slammed the door shut real fast. Cinco got tangled up in the blinds covering the window and the door.
Uh-huh.
And Cinco, I hate to think what he would have done if he'd grabbed that cat. That cat didn't come home for 3 weeks after that.
Wow.
My mom was really worried, but cats being cats. I mean, the cat just went out and hung out with the neighbors or something.
Yeah. But still, that's pretty bad.
Oh, Cinco did a lot worse than that. I'll save that for another time.
And probably good that you do. I don't know what it is, but I'm a little concerned.
It involves rabbits.
Oh. Well, now our imagination has run away, and we can imagine what happened.
Yeah.
Well,
Cinco, Samoyeds, they're like huskies.
Yeah.
I think they're very close to the wild.
They're high strung.
Little wolf in them. And,
Yeah.
they have instincts.
Yeah.
Come to the forest sometimes.
High strung.
Anyway, pink pillow.
Yeah. No, that's fine. I mean, I went off on tangents. You've heard me. So I can't, All right, we'll come back to this. Actually, this would be a good thing to examine with higher magnification, I think. This is 18 exposures. I'll save it anyway. Isabella, I'm saving it specifically for you because I know you like to process things. I will also try processing just to see what else is in the frames. It's amazing what you can find. All right. And now let's go check out something else. Here I am, we're talking about clusters, and we're actually going to nebulae because even with the full moon, almost the full moon, we're actually catching nebulae. They're a little brighter glow, but you know what? It's okay. Oh, there's the pink pillow. You can see it. All right. So let's pull out of this a little bit. Yeah. There's the neb. So that's up there. North American Nebula, the Gamma Cygni Nebula. I know there's, I think by now, let's go see if we can see it. I'm gonna back out a little bit. There's a lot of clusters here. We've done that. We've done that. Done that. I'm just looking at some things that we've done. I want to try and look for something in particular right now. See if we can catch it. Okay. It's over here. That's it right there. There's a few things we're going to look at. Okay.
I had a cat try to move in on me a couple of years ago.
What does that mean?
Oh, well, Tara talking about feral cats, it reminded me.
Oh.
I was outside after sunset
Okay.
one evening, and I stepped out the front door for a look at the sky.
Okay.
And here was this real cute little cat sitting out in my front yard. And
Okay.
it turned around and looked at me, and it came right up to me.
Okay.
And this was just the cutest little cat. It was white with like a gray cap on top of its head.
Okay.
And a gray saddle on its back.
Oh.
And it came up and started being extremely friendly to me. You know, it was curling around my legs and meowing and purring. And I gave it a scratch, and
it said, "Daddy."
pretty much. And well, I went back
cute,
in.
right?
I
That's
told
pretty.
the cat to go home.
Yeah.
And I stepped out a few hours later that night, and there's a big evergreen bush over to the left, to the right of my front door as you face the front of the house.
Yeah.
And I heard this rustling sound inside the evergreen. And
wow.
something was way back in there, and it was trying to get out. And my first thought was skunk. Okay, there was a skunk in the neighborhood at the time.
Yeah.
And I backed up. I was worried, and here it came, and it was that little gray and white cat again. And it came right up to me, and it raised its front paws and sort of half climbed my leg, and was just loving on me like crazy. And I picked it up and petted it and held it for a few minutes, and it was just having a great old time. And I put it back down, and I said, you can't come in. And I put her back down, and I went inside and went to bed. I told her to go home. And the next morning, I went outside, and that cat was still waiting for me. She came right up to me and jumped up in my arms and started loving on me again. And when I opened the door, the cat actually came into the house like it owned the place. And I called it and I said, "Stop, you can't come in here." And the cat came back out.
Yeah.
Outside, and I told it to go home.
Mm-hmm.
And the cat started walking up the street, and it turned around and looked at me once, and then it turned back around and started heading on up the street. The cat wanted to move in, obviously. I sometimes wished I had, but the cat had a collar on it, and it was purple, and it looked like something a little girl would put on her cat,
Yeah, it belonged to somebody.
Yeah, so I hope the cat made it home. That was such a cute little thing, though.
Yeah. This is a nice little planetary nebula near the other target we're looking at. This is this guy right here. It's called the Little Dumbbell, also known as the Barbell, the Butterfly, or the Cork Nebula. It's Messier 76. We took a lot of pictures of this here in SkyTour East with a telescope behind me. And now, yep. And then we have this guy, which is just now a beautiful rendering of this nebula. It's beautiful. You can see the colors. It has the same kind of coloring as the dumbbell for the same amount of reasons. And it has the same kind of shape. Again, for the same relative reason. Okay, if we zoom in just a little bit. Okay, you can see that it has the extensions like we see with a dumbbell. But it has a predominantly upper left to lower right kind of look to it, doesn't it? That's because this is what's called a bipolar nebula. It has lobes that stick out in two primary directions. This might be along the equator of the star as a rotator going this way. If the star was rapidly rotating, then the material might go out on the equator like that and make this bipolar lobes, and then less at the north and south, but more at the middle, you know, like that. And that could be why we see it this way. So I think that this could be exactly why we're seeing this as we are. So again, a lot of planetaries are indeed bipolar, and that's important. I think I need to address the focus again here, Daryl. So I'm going to go back to 1 second and just do some focus adjustment again and try that. Let's see what we got in here for focus. I think the star will be there. Let me get rid of the stack. If I just get rid of this, we won't lose what we've done so far. Okay. Okay, so we can use that star over there.
Check your temperature when you bring up the focus.
Yep, gonna.
Imagine it's cooling off there.
It
really
is.
cool.
I'm gonna guess 65. I'm gonna guess 65. Let's see what we got.
Let's get down in the 20s again here tonight.
Okay, this. What's the temperature in this building out there? 60. Okay. So yeah. Okay, so now I didn't mean to do that. Now let's bring this up again, and we're going to go and I hit that for sure. Okay. And now we're gonna go here, and I shall now try focusing again. Let's try this other focus factor, see if that makes any difference. I'm gonna go up by 500, see if it goes smaller or larger. Okay, wrong way. So we're gonna go smaller. So that's good to know. Alright, so we're gonna go back down to this. Stars get smaller. And let's go a little smaller yet still.
I was watching videos about Hyperstar the other day.
Okay.
You know, the guy, this one video, he was talking about doing collimation and all that.
Yeah.
He said one set of screws. It's like you have two different sets of screws around the
It's a push.
perimeter of the.
It's a push pull, yeah. Some push the hyperstar away from the base it's mounting to, and some pull it toward it. So you wanna pull it down to be flat against the secondary mirror location. That's the hole in the end of the telescope where there's a mirror normally. Well, you're gonna replace that with this big long lens assembly, and you want to pull those screws down so that's touching. I never did that. And then you loosen them, all right, and that now gives you some play, and then you push the thing away with the other screw. And you keep doing that around until that's perfectly collimated. And I never actually did exactly that. Okay, I'm going to change this to 49. 937 for now, just so I remember it. Now let's try this guy right here and watch what the stars do. Okay.
That looks worse.
It does. Let's see which way they go though. Looks like that's worse. Okay, good. See, with the collimation error, we can't get perfect. That's the problem. Can't get perfect.
Well, I wondered watching this video what the guy said anyway. Well, one of the sets of screws, he said, is what you loosen to rotate the camera. You know, to reformat your.
Yeah, that's yet another set of screws on there. Yes, that's correct.
Okay.
But that has nothing to do with collimation.
Yeah.
Okay, so that's not good there. Pardon me, folks, while we focus this telescope. Pardon me while I focus my telescope. All right. I think this is probably not good. Right. This here is better, but not best. Yeah, it's better. If I go up, did he come out and back in? Is that what's going to happen?
Softy, catchy monkey.
Yeah. Okay, I'm just dropping down little steps at a time here. This might be getting better for where we are. Hard to tell. That might be the best I can do right now. So we go to auto here. Now let's go back and do a 15 seconds on this guy. And go back to our live stack. I can continue from the same location I was in, but I don't want that because that was soft focus. So let's try getting rid of that and doing it this way again. So here comes the first one of our newly focused image. How's it look? Okay, right. Well, I got you. Okay. Let's go
This
in.
is still the dumbbell, right?
It's the little dumbbell, yes. Let's zoom in more. See if it's any better. Well, it's actually a little better for the focus anyway. But again, until I can collimate it, we get close, but no cigar. You know, that's all right. But we're seeing what it does, and that's the important thing. We see what it looks like. Let's put that black level down now.
Vera asks, how does the focuser work?
Oh,
I assume it's a stepper mode.
yeah, actually the focuser, you know, Vera, you know, on a telescope you have a knob you turn. Okay. On this, what we have is a motor that's on the focuser, replaces the focuser, and it's what's called, as Daryl says, a stepper motor. A stepper motor is a motor that knows every location it's at. It has discrete steps that it moves. Like, instead of just going zzz, like a motor that turns on, these can do that too. Zzz, but every step they take, every motion they take, they know exactly where they are. So, this particular stepper motor is at position 50,021, 50021. And 50022 or 50020 are different locations for this. And that's how they actually work. And if you go to one way to heck down on one end and then come back to it, you'll end up finding that it's exactly what it was before, because it can repeatedly come back to exactly where it was, because it's discrete steps that it's going in. And stepper motors can go, 250 steps or 50,000 steps or more, which is what this one is.
Micro step.
Yeah.
Excuse me.
All right. Let's do that. Now we'll save that. Okay. So, all right, so that's the little dumbbell. So now what we'll do is we'll pause. It's only been 10 frames, but you know what? Just to be consistent, I will save them. And then save exactly as seen, just like you see it here. All right, and then we can clear it and leave it. And then go to the other thing, which I know people have been waiting for, but they don't know it yet. And you know what it is, Daryl, but don't say. It's right nearby. It's right near here. They're sealed until people read it, and they read it in here. Yeah. So we're going to go here. Fish head, roly-poly fish head, eat them up, yum. Remember the fish head nebula we looked at? Yeah, that's not where we're going.
You said you a picture of the heart nebula?
Yes, you did.
It was interesting.
Yeah. Well, that's not where we're going. We're not going there. Okay, but we're going to be centering the star, which I think may be in Cassiopeia. And then, once it's centered, we're going to a beautiful cluster. And here it is, a beautiful jewel box, but it's not just one. It's actually two. And it's just a beautiful, beautiful cluster of stars, known as the double cluster. And I should have waited to focus when I got here, I think. Yeah. So we're gonna bring it up a little bit. There we go. That's the double cluster. Double cluster is great because it's so bright you can see it with your naked eye. And if you actually take a look at it with your naked eye, one of the things that you're robbed of is the fact that you can't see the color in here. There's some beautiful color stars in here, which we'll see here in a minute. When we go to the stack, we don't need many. You can see them. They're red. See that? Red, red, and red. Okay, now we clear this. Yep. And then just stack a few of them. Yeah, well, we're gonna.
Object too. It's a nice match for the wide field.
Yes, it is. Let's just try to normalize this just a little bit. And I'm going to do it by taking this off. Taking this off. All right, and now let's just try this and see what we get. And then this. Okay. Well,
Double cluster.
go ahead.
Strictly speaking, I guess it's in Perseus, isn't it?
Yes, it is.
But when you look up in the sky at it, it's like it's right between the W of Cassiopeia and the top of Perseus.
That's right.
It's really pretty.
It does look beautiful.
You can see it naked eye from a dark location.
Yep. And just so that you can see, in these shorter exposures, you can see these beautiful orange stars that are in it right there. See, 1, 2, 3. And there's another one up here. There's some red stars that are very red. These guys are undoubtedly M class stars that are the very, very red stars that are much, much, much less luminosity or intrinsic brightness of our sun, sometimes 100th, and you can only see them in a telescope. In fact, they're the most plentiful star in the entire universe. There's more of them than any other kind. However, you can't see them without a telescope. Yes, Vera, you are seeing in double. What's neat, though, is that I think it's this cluster here is actually further from us than this cluster, and not by just a little. This cluster is quite a ways further, or this cluster, I can't remember which one is the further one. It might be this one, is quite a ways further than this one. But and it's a line of sight thing where we're seeing one cluster at one distance and one cluster at a much other distance. But to us, it looks like a cluster where there are two things together, but they're actually separated by a tremendous amount of space. You got to remember the universe is in 3D. Yep. Daisy and Zoe, light pollution stinks. The filter I'm using in the telescope right now is one that can be used in such a location. Using it with this telescope in a dark location makes it even more spectacular, because it's got narrow passage bands that go through, narrow bands of light frequencies go through it, and that's exactly the kind of thing that we're looking for, is the light of the hydrogen alpha, that red that we see in nebula, the light of the oxygen emission that we see in the planetary nebulas, that turquoisey color, and then the hydrogen beta lines, which are more lines that show us specific behaviors and compositions within a nebula. So there's a lot of stuff that we can use, but this is gorgeous. So if I bring the stack up and let's remove the black point, like where it thinks it's black, let's move that over, because the stars are certainly not going away. Let's see if we just get drastic what it does. Yeah. See, that gets too much, but just to show you what that looks like. Okay, this is what it looks like when it's drastically reduced, and that's incorrect. But you can see how many small stars there are in there. There's many. This cluster has lots and lots of stars. All right, Cypher2, thanks for coming along. Okay, I understand you're going into the tertiary adjunct animatrix. That's fine. Got to regenerate. Just make sure you don't have too much of the kerfluffus, compound, because that could actually force the tertiary regeneration process to fail miserably. I've seen it before. But good luck with you, and just take care of yourself, man. But thanks for coming. We'll see you again. Remember, no kerfluffus compound. That's going to cause problems. Sleep is not futile. I am Locutus, a Borg. Resistance is futile. Well, it certainly wasn't, pal. Alright. So this is good. So I'll pause this now and save it. For those that want to take a pretty picture, they can have a pretty picture. I like pretty pictures. These are all going to be out on the server, like I told you. Okay. And now we'll clear it and move on to the next. I would like to look at something very nice. I think I got an idea. I'm going to come down here. We're going to the heart of the matter. Why not, you know? Let's see which star it's going to use. It's probably going to use, yeah, exactly, Seguin. Here's Seguin. And then it's going to center the Heart Nebula right here. And you'll see a little bit of it. Even at 1 second, even with a nearly full moon, you're going to see the parts of the Heart Nebula. Here we go. You can see the fuzzy already. You see the fuzzy nature of the Heart Nebula right there. And I'm not sure where the fish head is from this point. I could look actually and see actually. It might be opposite what we think it usually is at this point.
It was at the top right last time, wasn't it?
Yeah. So because in here it's opposite because it's flipped over, the telescope's flipped over the top. Yeah. So from this position, it's going to be just at the top right again if we got it right. Let's go see. Let's go see, shall we? It should be up here. So let's go and do 20 seconds. We're about as far from the moon as we can get. So let's find out if that works for us. Okay. Live stack that. And let's see what we get. Let's stack these photos on top of each other and get this signal out of the noise. Yep, that worked. Okay, so now we're just going to just sort of normalize that a little bit darker. Look at that. Even with a nearly full moon, we got a beautiful shot. There's the cluster powering this nebula, causing these nebulae to be excited and causing the hydrogen gas to be ionized and then recombine, have the electrons recombine with the hydrogen atom, the nucleus, I should say, and give off the red light.
See the fish head already.
Yeah. Hey, Cindy boy.
The mouth facing right.
Yeah.
Fish's eye just to the left of the mouth, and that dark curved line I always see is like the fish's cheeks, or like where his gills are.
That right there.
No, that's his eye.
Oh, that slit is the eye?
Well, the thing on the right is its mouth.
Oh, you're talking
Just
about
like-
this is the mouth.
Yeah, that's fish lips.
Okay, and he's about to eat a
Dark
piece of
shadow
plankton.
To the left of that is the eye, right there. And then if you go over to the left of that dark curved line, that's like the gills on the fish.
Right here.
Yeah.
Okay. I can sort of see a cosmic goldfish, I guess. Neat. Let's see if we can bring out some more detail here. Okay, that's more proper. Let's get some black point lowered, get some processing. That looks kind of cool. Wow. Alright, that's too much. Needs to be normalized across. It'd be a little brighter, but that's okay. That's cool. You can see a lot of stuff in here. And this is just a stack of 8 so far. If you look over here on the left, it says you right there. It's a 2-minute and 40-second stack so far. And we're adding to it 20 seconds at a time. So this next one will be a 3-minute stack, I would say. Okay. And then 3 minutes 20, and blah, blah, blah. Very, very cool.
The fish head reminds me of that fish sculpture I did.
What'd you do?
I showed the picture somewhere years ago. I think it was Bill's site.
Okay.
It was a metal, it was a steel sculpture of a fish I did.
Okay.
His head looked very much like that. Isabella saw it, I think. I think I sent her a picture or two.
All right.
You want to see it? I'll send you a picture.
Yeah.
Give me a minute.
All right. Yeah, so this is a really interesting nebula. And the moon's not out, it's just spectacular. So it's kind of hard to tell what it looks like. This is a little bit better. Alright. So you can see it a little more better. It's gonna be something that looks much better than this does when the moon's not out. Let's grab this. Wait our obligatory 1 second. Pull our curve in a little more. Drag our black point down a little more. Pretty good. Not bad. I mean, there's a really interesting location here. This is something we'd flesh out. Oh, I see it. That's actually a very cool sculpture, Terrell. Oh.
See the similarity?
I do. It's almost the same orientation. His pictures of metal fish.
I'm sorry?
I was telling people your pictures of a metal fish that kind of looks interesting. It looks kind of like the Fish Head Nebula. This is called the Fish Head Nebula right up here. Right here.
I think that fish head is upside down.
Yeah, so if you flipped it, it might look more like what you have. Cool. Yeah, those are the gills, There's the eye. There's the lips. And that's the little piece of plankton it's eating. It's grabbing some food. Okay. Well, let's see. Where'd you go? Okay. We're going to go to one more object. I'll pause this. We've done 19. And I will save it, even though, it's not the best night for this. Okay. Sorry, I started on. Oh, man.
Bella has a question or two for you.
Okay. What did you say? Here's Isabella's question is flat field processing. Basically, what is it? Well, if you notice, in the pictures we took, the center had sort of a glow, and the edges were kind of dark. You really want that to be the same brightness all the way across. So how do you actually do that? How do you make a flat field image? How do you get that? There's a number of ways. That the way the sensor responds to light hitting it generates the flat field artifact. Okay, it's more sensitive in the center, less sensitive around the edges, perhaps, but you want a generic version of what that looks like. So without stars or anything. So what you do is you will go to, say, a location in the sky during the like dusk where there's no clouds, and you just take a picture. And that picture can be any amount of time. It doesn't matter. What matters is how the sensor responds. You get a brighter center and a dimmer outside. You can make that a generic flat field that you then do the following with. Every star image you take that you want to keep, you then take your flat field and subtract it from your star image. And when you do that, it removes that flat field. It removes the brightness in the middle. And it does nothing near the edges if the edges are darker. And it kind of makes it the same all the way across. Then when you process, it will make it so that you have a even brightness across the screen in terms of the background. And then you can pull your data out and it'll look really pretty. But that's how the flat field process works. And I think that was your question, Isabella. So it's not only just for stars or nebula, it's actually for every picture you take, because it's a camera correction mechanism. Right? So anything can be when you take a picture of anything, you do it in a flat field manner. Okay. We're going to go to one more object tonight.
Just one more.
Just one more. This is the one more. And with the moon, I have a feeling that this is probably going to be the better one. So, we're going to go to the Andromeda Galaxy tonight and see how it looks tonight. So you watch the telescope here, you'll see that it's going to move. It's moving quite a bit right now. And it's going to find... it's going to find the star that it needs. And we're going to do this.
Isabella has a follow-up for you.
Okay. Yes, I make flat field images that I use in my Photoshop processing, Isabella. So I can actually my actions, the actions, the little programs I wrote within Photoshop, I make a synthetic flat field. You need to make a different one for each photo. So I make a synthetic one instead of taking an actual photo. I actually build one from the existing imagery. And that's an action that I've written so that you just click the button and follow the instructions that I write on the screen, and you can make your own flat field. So in the actions, I'll be able to show you how to do that. Okay, that's the Andromeda Galaxy now. It doesn't look like much yet, but trust me, in just a minute, it's gonna look great, I'm telling you. Okay, right up there is measure 110, I believe, and this is measure 32.
Yes.
And then this is measure 31, Andromeda Galaxy. And to see the Andromeda Galaxy in full living color, then what we have to do is take this and give ourselves, say, a 25-second exposure. And then get rid of this here. So there we go. 25 seconds off and running. And then let's see if I have to clear a buffer. I do. All right. Okay.
Tara, yes, it is.
What's Tara asking?
The galaxy is on a collision course with the Milky Way. Yep, it's coming toward us, and I forget, a billion, 2 billion years from now, they
Yeah,
say they're going to hit.
a couple billion years. Yeah.
Couple billion.
Yeah, and you know what?
And they'll basically go right through each other.
That's right. And it's going to change the nature of what we look like as a galaxy, and maybe change the nature of what the Andromeda Galaxy looks like as well.
And if you want to get an idea of what's going to happen then, look up colliding galaxies. Look up the antennae galaxies.
That's
or
right.
The, what's another pair?
This galaxy
antennae.
and Triangulum, which is nearby, the Triangulum Galaxy may have been affected by being in close proximity to the Andromeda Galaxy. M82, the Starburst Galaxy, is near M81 in space. And M81 is a big spiral galaxy that we'll see, trust me. And M82 is one that we'll see, of course. And M82 is what's called a starburst galaxy. There's a lot of stars forming there. And it seems to be just bursting out with new stars. And that's something that is caused by interactions, they think, with Messier 82. Messier 81, I mean. So the spiral galaxy proximity to Messier 82 is causing this to happen. That's the thought so far. Okay, I'm going
if
to.
you do a search for colliding galaxies,
yes,
some really cool pictures will come up.
Agreed.
They look like what Andromeda and the Milky Way will look like when they collide.
Yeah. And it's going to make a whole new breed of galaxy. See, with a full moon out, it's actually affecting our. It's affecting a great deal of our processing capability here. It's okay. I don't mind. I don't mind. It's just got a little, way too much red going on. Let's see. The Andromeda Galaxy does have yellowish stars near the center, but it's really a little bit too. It's too bright. It needs to be toned down, and that's part of the problem here. What if I do this?
Why did it turn so yellow?
Well, that just has to be. It has to do with the full moon. Okay, so as bright as the Andromeda Galaxy is, the edges of the Andromeda Galaxy do, in fact, compete with the brightness in the sky of the full moon.
Yeah.
So we do have to worry about that.
Moon's probably hit that the hardest of any image tonight.
It has, yeah. I agree with you 100%. I agree with that. Yeah, I just keep.
Some of that could be compared to some of the nebulosity we've seen earlier in the evening. The light of the galaxy is broadband by definition. It's
Yeah.
All sorts of wavelengths in there, whereas a lot of the other stuff we were seeing was discrete emission from hydrogen and oxygen and stuff. And,
Yeah.
It's really fighting the moonlight.
Yeah, it is. Okay, this will give us the better curves, but we need to move out. At some point, I'll explain all the curves and how this all works. Yeah. You know, the other thing is, I haven't checked the all-sky cam to see if there's any clouds out there. I didn't see any, but we did have high-altitude clouds one night that we didn't notice.
Yeah.
So,
I stepped outside when I was away earlier, and surprisingly, it cleared up here.
yeah.
It was cloudy earlier.
Well, we're going to try to see what we get from here. This is just an 8-second exposure. We're going to see what it gives us.
You know, in 2-3 weeks, Orion is going to be up at 10 o'clock at night.
Yeah. We'll still have to wait for it.
Yeah. We'll gain an hour back once we go back to standard time, first Sunday in November, I guess.
That's right, yeah.
It's already, Orion is up here by 11:30 at night.
Okay. We actually, look at this, see this? We do have some light clouds out there, guys. So we did okay, and now the light clouds are sort of taking over. That's why the Andromeda looks as crappy as it does. So you got some here. Yeah. Okay, well that tells us, that's good. So at least we know that what happened to our night sky tonight. Unfortunately, that gives us very little that we can do now. So what I'll do is I will go back to our 1 second shot, and we'll go to this, give ourselves that. I'm going to pause and clear because we can't possibly get a good shot now because of the clouds. That's what the all-sky camera is good for. You know, lets us know when it's happening. Yeah. You can actually see that this looks rather different from how it's looked before. It's actually very hard. Okay, so here's what we do. We will be shutting down for tonight, but what I do want to show you is the close down procedure. It's kind of cool. First things first, we disconnect our focuser and put it to bed. Okay, it's gone. That's good. Next thing we do is we disconnect our planetarium system. But I can't do that until, for some reason. Alright, let's just do this. Shut that down. And then I can shut this down. Okay. So now we disconnect the telescope from the planetarium system. Exit that. Yes. Okay. Alright, so now we are ready. Now we can go do what's called park the telescope. So I'm going to hit park. And that's going to bring it to a predetermined location. And it's going to park the scope. And you'll see where it's going because you can watch the stars zipping by right here. And it moves to a horizontal position that makes it much better for the telescope to keep dust off it and so forth. And then you see down here, right there, it says scope is parked. You can turn it off. And so when I come over here to our astronomy control program, which I didn't make too exciting, I realize, I'll hit this. It's going to turn it off. You'll watch this go off. The telescope's going to shut off. And it'll tell you, turn off pure power. Telescope is now off. And the interesting thing that happens is when we look here at the screen, it's still very cool because even though this is facing the wall, we still get to see some stars. But I'll put the cursor here and check this out. You notice the stars are moving, right? They're moving. And why are they moving? They're moving because the Earth is rotating out from under them. We're actually seeing the rotation of the Earth visually. something that people don't generally get to see. Okay, here comes a bright star. It's coming into the field. It's reaching the point right now, and it's about to pass by the point. There it is. Okay, so you're watching, the telescope's not moving, it's off, but you're literally watching the rotation of this gigantic planet you're sitting on right now. I think that's pretty cool. So we're done with that, so we can disconnect the camera, and like that. Now that the camera is disconnected, we can shut down the camera control program. And just to be fun, what I like to do is bring this over here and make it a little bigger so you can see it. Kind of neat. Okay, so here we go. And the next thing to do, because the roof is on the off the telescope right now, next thing to do here is to disconnect the telescope. So I'm going to click on disconnect the telescope up there, and now the telescope will disconnect. You'll see it when the lights turn off. The telescope has been disconnected, and there we go. This is our close music. All right, so there we go, and now we're going to close the roof of the telescope. So you'll see it happening now, 2,500 miles away. And the telescope's being put to bed for the night.
Yeah, I'm going to go to bed too.
I think you should, considering that it's 2 a.m. for me almost. So it's 11 a.m. for you, right? Or no, 12 a.m. for you.
Yeah, almost midnight.
Yeah, okay. Well, there you go, folks. Thank you so much for joining us tonight. I had a great time with all of you. So did Daryl, if I can speak for him.
Sure.
We had a good turnout. A lot of people enjoyed our company tonight. Daryl, I think you did a fine job. Thank you for joining me tonight.
Thanks for having me.
Of course. You're the man around town, man. So it's cool. As I call you, the astronomer's astronomer. It's kind of fun having you around, you know?
You call me.
I do.
Okay. Well,
right.
Thanks for having me, Mark, and good night, everybody.
Okay.
Good morning, Isabella, and everybody take care, please, and we'll catch you again.
All right, Daryl. Thank you. I'll see you later.
Take care. Good night.
All right, bye, Daryl. Well, that's it for tonight, guys. Thank you so much for joining. And what I will do is the next clear night, we're going to wait till after the moon is full. And once the moon is on the backside of its cycle and is heading toward waning gibbous or waning last quarter setup for the moon, we will have a lot more we can look at and do more dark sky views. But it was fun checking out clusters and things we did tonight. You guys are a lot of fun. Thank you. And to those who donated, I'm humbled. Thank you so much. You help keep us going. When we have Starlink, we're going to actually then be incurring real cost. Right now, the observatory is green, meaning that all of our power comes from the sun, and the cost to us is nothing from the people that own the land. We ran electrical cables underground, trenched them, and we have to do upkeep because critters do chew on our cables. I noticed one of our network cables, our primary network cable, actually has been chewed. I think Tara's the one that found that. Tara is here in the chat. But we will be doing work on the observatory in November coming up to keep it up to speed. And if for some reason our Starlink is in by then, we will be putting up Starlink as well. And Starlink is going to make our speed 20 times what it is now. Think about that. That's pretty good. All right. Well, you guys have a good night, and we will talk again soon. I really enjoyed spending time with you, as I know Daryl, as he said he did. So you guys have a good night, and we'll be back. This is SkyTour LiveStream, and remember, keep looking up. Talk soon.